So we have today Methodic Exuberance Volume 2, super exciting. And like we have with us Pedro Venegas-Rodríguez. He's your tutor today. Pedro is an architect, professor, procedural and computational designer based in Lima, Peru. I would characterize him as a really like a technical guru. He's really amazing with everything, like, all softwares that are relevant today, like amazing problem solver. He holds a Master of Science in Computational and Advanced Design from our design morphing program. That's how we know each other so well. So it's really amazing to see him, like teaching after the program and expanding his knowledge and, being such an active part of the community. He's a co-founder of Lima Labs, and a computational design laboratory based in Lima, Peru, where he explores the limits of digital tools through digital prototypes and fabrication. He also works as a professor at the technical department of the Pontifical Catholic University in Peru. He's worked also in several offices such as Monterey, Elusor, Exove as a computational designer. So I'll hand it off to, I'll stop sharing and hand it off to Pedro.
Thank you so much, Paulina. So, should I share my screen?
Yes, I just want to say a reminder for everyone, because I know that, we have a lot of questions about the webinar. If you guys just the reminder is more about the recording. It's going to be a recording from this webinar emailed to you a couple of days after the webinar. So if for any reason, you can't follow the full webinar, that's totally okay. You're going to have access to this recording in a couple of days. So just, keep watching the live session, even if you get lost through the process. Pedro, just check if your chat is switched to everyone. I think that's the only thing that I would like to
Sure,
check.
it is.
We're good to go. Thank you.
Thank you so much, Paulina. I'm going to share my screen. Let me see. Not this, but this. So, I'm very happy to be here again for the second episode of Methodic Exuberance. I hope you can see my presentation here. I have a very small presentation, just to introduce you a little bit more about this concept of exuberance, which is quite very interesting from my side. So I'm gonna guide you through this very brief presentation. So basically what I want to show you here, what I want to explain you here first, it's basically who I am in a way, what I'm planning to do, what kind of softwares I'm planning to use, the methodology that is basically guiding the work that I usually do every day. And then I'm going to explain you a little bit about each exercise we're going to go through today. So in order to know more or less what we expect, what I expect to show you in the next 5 hours, we have a lot of things to do today. So I'm going to try to be, I'm going to try to explain as much as I can, even though if we don't have time to go in very detail in each exercise, the good thing is that you have access to all the files that I'm going to show you today, and a lot of graphical resources and stuff like that. So you can follow me on my Instagram accounts. I have two. The first one is from my personal office, which is called Lima Labs, and my other personal, which is Pedro Rodriguez. You can follow me there. You can send me messages anytime you want. I'm really happy to meet new people every day. So as Paulina mentioned, I mostly work as a professor and researcher here in Peru. I also work as a tutor in the design morphing master, by the way. So basically, most of my time it's invested in academia. So, but Lima Labs is more like my personal space for research, where I do my own explorations. I had the opportunity to teach in different schools, not only in Peru, but around Latin America and around the world as well. So what I think about exuberance, the term exuberance is not it's not about the complexity of an object per se. So the way how I see exuberance is more about the complex of the process of modeling something. So the idea behind exuberance, or the word exuberance doesn't have a direct relationship with something that is digital or physical. It could be both. So, but the goal here to think about exuberance, it's more about the complexity of the process, a process that could create an object. So this object could be physical, it could be digital. So basically, we are like entering in the realm of iteration, something that could be iterated. So at the end of the day, the object per se is not that important, but the process itself. So basically, we are gonna focus more on designing the process rather than the object per se. Even though at the end of the day, object's important, scale is important, material is important. But when I talk about the exuberance, I'm referring more to the process, to the complexity of the process rather than the object per se. So in this case, this personal exploration is physical, but for obvious reasons, when we start talking about the digital world, I think iteration is more obvious. And mostly we are going to focus on the digital world rather than the physical, for now, at least. So this idea of iteration, it's something that it's been really common since a couple of years, since some softwares were more popular, like Houdini, for example. The thing is that not all the softwares has this ability to focus more in the designing of the process, but the object. So along these years, I've been really interested in different softwares. I try to learn as much software as I can in order to look for like the proper tool in where I can focus more in designing the process itself rather than designing an object. That's how I came to Houdini as the last tool that I've been using in the last 2 years, also almost 2 years now. By the way, I learned how to use Houdini during the master a couple of years ago, and I still use it now. So this idea of iteration, and I know most of you are quite familiar with this term nowadays that we use generative AI, and that's something really common. So thinking about iteration now, it's something really common. But some years ago, it was not so common to talk about iteration, but just designing the object. So when we talk about iteration and the way how I think about iteration, it's not about impressive images or stuff like that, but it's more the idea of the creation of patterns. So my base point starts when thinking in patterns, but not necessarily natural patterns or patterns that we can find in nature, which is okay, by the way. But I'm focused more from the perspective in where patterns can be created synthetically. So we can create patterns using the power of computers. Patterns that doesn't need to have relationship with nature. So there are a lot of ways to create patterns. And I try to explore this way of thinking at the university. So basically here in Peru, I work in 2 different schools. I work in an architectural school and I work also in a fashion design school as well. So I try to apply this rhetoric in 2 different scales, in architectural scale and in human scale as well. So for example, something that we started doing this year at the university here in the architectural school was to kind of study natural patterns in order to reimagine it synthetically using generative AI tools. The goal here was to kind of identify codes that could give us the potential to start designing objects based on patterns that we found on nature or synthetically. So the idea here was to design the process rather than designing an object. So tools like Houdini in this case was extremely important, as we were more into this idea of iterating a process or making the process complex. So the goal here was just try to reimagine or identify codes using the computer, but in a very particular point on or stage in this process, we start thinking about scale. So there were a point. So there were like a time in where we didn't care about the scale. We didn't care about the object per se. But of course, scale, of course, objects are important. So once we identified codes using patterns and using the computer, we reached to this point in where objects start getting three-dimensional. So once we assign a scale, once we assign a function in a very particular stage on this exploration, we reached to this point in where patterns could have the ability to transform into objects. Those objects could be architecture, could be jewelry, could be urban design, whatever. So this approach is very interesting in where we start studying patterns, computationally patterns, and to a certain point in this exploration, we had the ability to give those patterns a particular scale or function in order them to be transformed into objects. In this case, the goal was to make them physically, even though almost the whole exploration was digitally. On the other hand, we also had the opportunity to study patterns computationally. So without any kind of influence of natural patterns. In this case, we try to design patterns just computationally using Houdini, just by using noises. And that's something we're going to do today, by the way, in a way. So in order them to be used to create other kind of objects. So in this case, we created human scale artifacts, for example. So that's I think that's a good approach regarding the study of patterns, in where we can assign scales to at the end on this process in order to create objects. In this case, they were avatars. Okay, so today we're going to focus on this particular software, basically Houdini. Basically for its capacity to iterate faster, to design a process, because we need to be focused. We need to focus on the process itself rather than the final object. So this particular way of thinking could sound a little bit weird because we don't focus on the object. But at the end of the day, we can assign a scale, we can assign a function to our design in order to obtain the final production. Let's call it that way. So Houdini is this kind of software that could be quite a bit hard at the beginning, but be patient. This kind of software requires you to be patient, sorry. So, but basically, this is how we organize Houdini. So we have like a viewport in where we can interact with the software manually. And that's something that I usually do. We have like another type of viewport that it's called geometry network, in where we give instructions, or where we create the process itself, or we design the process, as I should say. So there are like 2-3 ways to interact with Houdini. One which is manually through the viewport, then through the geometry network, in where we give commands, we assign commands, we give instructions. Then we have the parameters view, where we see the parameters of each node, like the actions each node is going to do. We can interact with the parameters view tab manually as well, or we can like change parameters by editing our object manually as well. So there are a lot of ways to interact with the software. And finally, something probably this is it could be quite a bit new for some of you. We have an attribute tab, or something that is called geometry spreadsheet. So the idea behind the attributes, and I think this is quite new for some of you because this is not really common in Grasshopper, for example. The attributes are this kind of a space in where we can see what kind of data we are like creating or editing, because we have a lot of data going on and happening at the same time in parallel here. So a good way to see what's going on or what's happening or what kind of data we need to deal with, it's by interacting with the attribute. This is the kind of monitor or panel, if we should say it that way, from where we can see what's happening in the system. The good thing about attributes is that we can interact with the attributes. We can take data and move it, tweak it, change it, transform it. That's something we can also do here. We are not going to focus too much on attributes, at least for today, because as you may see here, Houdini is a really deep and complex software. So I'm going to try to stay in the surface, just for all of you to get familiar with the software first. That for me is the most important thing. Well, and finally, we at the top have our tabs and ribbons, all the commands that we can use in Houdini. What I really suggest you is try not to play with those, because Houdini in that sense is quite a bit tricky. The commands that are up here are more procedures than just components. So try not to play with them, not until a point that you are really familiar with the software. So in the meantime, we're going to communicate with Houdini just with the geometry network itself here. So at the end of the day, we have more control over the software, right? So it may seem that what I say, it's more like a puzzle for you, but Houdini requires patience from us. At the beginning, you will feel that Houdini is really hard to control. It happened to me once I started using Houdini. But keep this in mind, as Houdini is an extremely powerful software, you just need to be patient. So once you understand the logic behind Houdini, you will feel that the way you work is going to change dramatically. once you get comfortable with Houdini, probably you'll stop using other softwares. Okay, so be patient, bear with me. I am not gonna work really complex things today. I just want you to get familiar with the software, even though we are gonna use AI tools here. If you have any question, if you have anything to comment, please let me know. Use the Q&A box. You can use the chat as well. And so, to finish this presentation, I'm gonna explain a little bit, very briefly, what I'm planning to do today. Okay, we have like 5-6 exercises for today. I hope I can go through all of them. So first of all, even before entering in the AI world today, I want all of you to get familiar with the software, because there are a lot of things going on in Houdini at the same time. So it could be quite a bit confusing if we go directly to AI tools. So the first thing we're gonna do is we're gonna get familiar with the software. We're gonna do some basic pattern exercises. Basically exercises based on attribute modification, groups creation, and so on. Okay, this is going to be our first exercise. We're going to design this kind of yearly-like gemstone object. Okay, keeping in mind that our goal here is to have control over the iteration rather than the object per se. That's why you see here, I'm going to show you just iteration. So this is our first exercise. Our second exercise is going to be this kind of exoskeleton. The goal for this particular exercise is to get familiar with the grouping commands or components in Houdini. We have two ways of controlling iterations. The first one, it's more like digitally, just by changing numbers. And we can also have the possibility to iterate something manually by interacting manually with Houdini. So that's the goal for these two first exercises. After those two exercises, we're going to make a 10 minutes break, okay? Just to breathe a little bit. So I hope later you could make your questions. It's going to be fine if you have questions. If you cannot follow me to this point, it's okay. You will have the video later. You have all the resources that I already sent to you. If you don't have the link, I'm gonna send the link as well with all the files, all the resources, and so on, that kind of things. So after the first break, we're gonna make our first attempts to work with AI assisted resources or assets. So basically, even before going directly into Stable Diffusion, that's going to be our main tool today, we're going to make a small exercise using Midjourney. I am not planning to show you how to use Midjourney because this is not a Midjourney webinar, but we are going to use assets that we could create in Midjourney. Basically, this is the first exercise that I did when I started using Midjourney. I tried to import assets that I made in Midjourney, even before Stable Diffusion was available in Houdini. So the thing here is you can copy this prompt. Feel free to use it. I used to use this prompt back when we were using version 4 on Midjourney. But you can copy this prompt. Probably later I'm gonna copy paste it on the chat. It's okay. So our goal here is just to get familiar with importing assets in Houdini. That's something that we can also do. So probably this is the first time probably most of you will work with COPs, which is basically the environment in Houdini where we can start dealing with rasterized images. I'm not gonna go deep into this particular environment. As I think tomorrow there is another webinar in where you will focus more on the COPs network. Then I have a question regarding MLOPs, and I'm gonna try to answer this. After this first exercise, I'm gonna introduce you to MLOPs. Basically, MLOPs is this plugin. MLOPs stands for machine learning operators, which is basically a tool that was developed for Houdini, where we can use Stable Diffusion natively inside Houdini. The good thing about using this kind of tools inside Houdini natively is that we have the potential to iterate faster, to combine methodologies, to run several instances of Stable Diffusion at the same time for obvious reasons. That means we need a lot of computational power. Okay, that's something I need you to stay alert, because we are going to invest a lot of computational power here, at least on this stage. But it's okay. It's okay. If we have time, maybe later, I can teach you how to prepare a very quick render using Karma, which is the native render engine in Houdini. So, but this is going to be like at the end of the today's session, hopefully, if we have time. But the goal here is that if you want to use MLOPs, I really suggest you to use the breaks to try to install it. For that I sent a guide of how to install Stable Diffusion or MLOPs. Basically, as far as I know, this works on Windows. I'm not sure if this works on Mac, honestly. But I just tested it in Windows. So this guide is on this link. If you didn't receive other files, it's okay. I'm gonna share this link to you just after my presentation. So on this, I have a guide in where I'm explaining step by step how to install it, because it could be quite tricky at the beginning. But I try to make this very detailed explanation of how to install it, what kind of libraries you need to download, and etc. etc. Okay. After this second exercise, I think this is the fourth exercise. We're gonna take another 10 minutes break. So if you wanna install MLOPs, you could take this 10 minutes break. And then we're gonna come back for the final 2 exercises. Okay, those two final exercises are gonna be more straightforward, more oriented to hard surface modeling, basically. So we're gonna use MLOPs as well to create patterns in order to make some extrusion exercises. This is going to be really straightforward, nothing complicated, honestly. But we will need some computational power here, because running Stable Diffusion, it's heavy. And running Stable Diffusion while doing a live stream, it's heavier. So bear with me, be patient. Each time we try to iterate Stable Diffusion here, probably you will feel that the session will go slower, but it's okay. So basically, MLOPs stands for machine learning operators. So this is a funky way to say that we are using a machine learning tool inside Houdini. The good thing about this kind of tool is that we can use it as a generative AI tool, as a regular generative AI tool, just to create images, or we can train it with our own data. And this is something that I'm going to try. After this exercise, we're going to make some 5 minutes break just for you to be sure to test MLOPs again. And we're going to come back to the final exercise. in this final exercise, we're going to try to guide MLOPs in order it to do something that we really want it to do. So I was trying to train MLOPs for this session, but my library is not ready yet. I think it requires more time and more input. So what we are going to do, at least for this exercise, maybe on another episode of Methodic Exuberance, we're going to go directly to the train sets. But for now, we're going to use the guiding parameter of MLOPs in order to more or less try to pre-train MLOPs in order to get this kind of architectural objects, let's call it that way. Okay, probably this final exercise is going to be quite a bit heavier. So I warn you, be patient. Using MLOPs, it's quite a bit heavy. But it's okay. Keep in mind that after the session today, you're going to have the video recording, so you can test it out later. So it's fine. It's fine. So I think that's basically the introduction. Oh, yes, the bonus track. I forgot the bonus track. If we have time, I will teach you how to make quick renders using MLOPs, because it's also possible. You can also make quick renders just for testing purposes, by the way. Hopefully, if we have time. If we don't have time, because as you see, we have a lot of things to cover today. On the files that I already sent to you, and if not, I'm gonna copy this link. I'm gonna paste it on the chat. Okay, on this particular link, you will find all the files and assets I'm planning to use today. For obvious reasons, you are not gonna find MLOPs because you need to install it in a very particular way in each computer. So feel free to do it during the breaks, or not. You can do it later, so you can watch everything that I'm going to explain to you. I'm going to try to cover at least the first exercises in detail. So then, if we have time, I'm going to explain in detail the latest, the final exercises. If we don't have enough time, it's okay. I'm going to explain the process step by step instead of doing everything from scratch. Okay. So with that said, we have a lot of things to do today. Let's organize my board. I'm going to have this here, and we're going to go directly to Houdini. Great. Just in case, I'm going to have my own documentation next to me. So it's okay. I don't do Houdini by memory. I always use references. I always use my notebook, because this is something that you need to do always, to have a notebook next to you. There are a lot of things happening in Houdini. I also have my notes here in a notepad, because there are a lot of things to cover in Houdini. I have some codes that I typed here. I'm gonna share it to you. I'll share them to you as well later. So no worries. Each time we want to create some components, I'm going to share those scripts to you as well. So let's start. First of all, this is how Houdini looks by default. I don't like to use Houdini with this particular organization. So what I usually do, I like to use Houdini this way. So let me explain to you how to create this kind of environment very quickly. So basically here you have this icon here, this kind of triangle icon here. Let me open my Epic Pen tool. I always like to do some notes while teaching, and I forgot to open it. Yay. So I hope you can see my notes. If you don't see what I'm drawing, just let me know. But I'm going to assume that you can see it. So basically here in Houdini, you have this icon, right? You have this triangle icon, and where if you click on it, you will see some options here in Houdini. One of them is called split pane. So I'm going to click on split pane left, right. This is how you create viewports in Houdini. This is quite a bit similar than Blender, I think. In Blender, you can do this kind of separations very quickly. By default, I am just duplicating the viewport. I don't want to do it. I want to have here the network view, which is basically the main space where we are going to create the nodes or the components. Keep in mind, in Houdini, we work vertically, and this is something different than Grasshopper. For example, in Grasshopper, we go from left to right. Here in Houdini, we go from top to bottom. But here in Houdini, we have another environment in where we can go horizontally as well. So it's like we have a small Grasshopper inside Houdini. So the way to change it is by clicking on this new tab button up here, and I'm gonna create the network view here. This is the space we are gonna work. We're gonna use to run our components. Okay. On my personal user interface that I created, I have several tabs because you can create several tabs. So in my particular case, I have 2 network views because I wanna always work. I wanna also I really like to see different workflows at the same time. I also have another tab that is called stage. This is from where I do renders. I have another tab that is called scene graph tree that basically shows me attributes for the rendering assets. So all the assets that are gonna be rendered have their own attributes. So this is where I can see them. The same here. And finally, I have another tab that is called task. This is from where you can manipulate and automate Houdini. So you can automate the whole Houdini in order Houdini to make the task for you, something like that. So today I'm not going to focus on TopNet, but TopNet is a really powerful tool here. I am not going to focus with it today. So this is basically how I organize my own Houdini. Just for you if you have questions. So for now, I'm going to keep this into the object tab. Then here at the right, we have the parameter tab, which is fine. We're going to see here all the parameters. But down here, by default, we have the network view activated, and I don't want it to happen. From here, I suggest you to have the attributes panel, or what it's called geometry spreadsheet. So in order to activate, we need to go to this plus icon, new pane tab type, and this is an inspector. Okay, the geometry spreadsheet is inside inspector because basically it's like a monitor, and this is basically how we work or at least how I work in Houdini. You can save this environment, this user interface, just by going into this build icon and save the current desktop. Just as simple as that. You can put the name you want. In my case, I put it Lima build, and this is mine. Okay, so let's start. I'm gonna turn my camera off for now so we can focus basically on the video itself, on the recording itself. So the first thing we're gonna do here is we are in an environment that is called object by default. So if I click on it, you will see that we have those names. We have CH, IMG, Mat, and so on. Those are different environments in Houdini. Each one of them are focused on different aspects of a production. The object tab, or the object environment, is the environment in where we can create an object, edit an object, or everything that is related to objects. Then we have material, we have an image environment. This is more like Photoshop. We have like the out environment where we can set the render. We have stage when we can create the production of the render, and task from where we can automate Houdini. All of them are independent environments, and all of them have their own components. So if we plan to model something in the stage environment, obviously we won't be able to do it. So I'm gonna, by default, the object environment is activated, but I'm gonna click on it. So if we press tab on the network view here, if we press tab, we're gonna see all the components that are available on this particular environment. By default, here we don't have too much geometries components because the object environment needs something that is called container. If we are going to create an object, we need to go to the geometry and geometry component. This is basically a container. So that means that our whole procedure or workflow is going to be inside this container. This geometry node is more like canvas, like an empty canvas from where we can start designing something. So this is going to be called, let's call it object one. Okay, then I'm going to go inside this object, double click on it. And now, as you may see here, we are inside the object one container. And this container, it's on the object network. Okay? So it's like we are, and it's like we are like creating a hierarchy, like a tree in where one object is inside another object and so on. This is how Houdini works. Okay, so we can go deep into one object or one level of an object. The thing is that if we go back, we can go back by pressing the letter U. So if you press the letter U in your keyboard, you can go up, or in this case, we can go back. So from here, for example, in the object network, we can create different containers for different objects. So for example, here, I'm going to copy this because today we're going to do first 2 exercises. Okay, so this object one container will contain the first workflow and the same for the second. This environment, by the way, is the one from where you can create, for example, cameras. So here you can create your camera, or here you can place your lights, for example. Okay, this is why the object environment is important. So if each time you want to control or edit your camera, you do it on this level. Then if we go back here, there is no camera here because camera works in an upper level. Right. So we're going to start by creating a sphere. Let's do very quickly. I always like to change. Let me share this. Let me see if we can revert to defaults. Let me see. Okay. I'm gonna delete light for now because it's giving me some errors. Great. That's fine. So I'm gonna create the sphere again very quickly. Okay, this is how we start in Houdini. I'm going to start with a sphere. I have this palette tab down here. If you press Z in your keyboard, this palette will appear. I always like to work with this palette because I like to change the shape of my components depending of hierarchy. So by default, we're going to start with this particular sphere, but I need to change the topology. Okay, this particular topology where we have quads and triangles is not the proper topology for what we are going to do today. So I'm going to change it here in the primitive type by clicking on it and changing to polygon. Now my topology is more regular, and this is what we need for now. So from here, we can change a lot of parameters here. Okay, just by changing frequency, by changing it, we can change the scale, we can change the radius. If we can interact with the radius, for example, we can change it manually just by typing the number. Or what we can do is we can press the mouse wheel. So if I press the mouse wheel on any of those parameters, you will see this kind of ruler, sorry, from where you can modify numbers more quickly. Okay. You can also interact with the object in the environment. So for example, if you click on the viewport, and that's how I use normally Houdini, because I hate to interact always by changing numbers. For me, it's quite a bit tedious. So I found this other method in where if you click on the viewport and you press enter, you will activate those parameters of the component, but you will have the possibility to change it manually. And for me, I think this is even better. And even if you press the mouse wheel, you can also see the parameters, as you may see here, right? So this is another way to interact with Houdini. So most of the times I'm going to be interacting with Houdini manually in order to have more control over the software, right? So for now, I'm going to keep this into 0.5, that it was the default. And center is going to be 0. And the frequency is going to be 50. Okay. So then I want to deform this particular object. As you may see, we can deform it just by changing shape here. So I can move it, I can change frequency, or I can press enter here and I can change shape. But I would prefer to keep this this particular geometry without any change. But then I'm going to use another component that is called transform, not trace, but transform. Okay, let's use transform here. So basically transform is this component that gives us the possibility to translate, to rotate the scale of our geometry. So I always prefer to use this component right after the main one in order to keep the original geometry as it is, as original as possible. So here, what I'm going to do is I'm going to scale it like that in the side direction in order to have this kind of ellipse here. So the next step is to deform this mesh. So something that I usually do in Houdini is to deform a mesh using noises or patterns in a way. So there are a lot of ways to transform geometries using patterns. So the most common one is the mountain sub. Okay, this particular component, I'm going to move this. Okay, this particular component by default give us some default parameters that where you can, for example, change amplitude, change the size of the noise. Okay, you can change the noise type, for example, and you can start changing your geometry like that. We can turn the fractal off in order to have more smoother geometry. And as you may see here, this is very straightforward. So it's very easy to change shapes in Houdini. But this is not the sub that I'm going to use today. But you can use it if you want. So let's keep it like that. I'm going to change color. I'm going to put black. But the one that I'm going to use, it's something that is called attribute bob. Okay. And this may be quite new for some of you, but if you see here carefully this mountain component, it's in reality it's an attribute noise. So basically we are like we are editing the attributes, and attributes are data. So all the information that you can see here are data. Basically they are attributes. So basically what Houdini is doing, it's changing attributes. But we can have more control over those attributes. So from here, I'm going to call this noise deform. As you may see, once we create an attribute bob, we cannot see anything. There is nothing on the parameters. It's because the attribute bob, it's more like a container. That means that we can go inside the attribute bob. If we double click on it, we will see this. This environment, it's more similar. It's similar than Grasshopper. We go from left to right. Okay, the attribute bob is basically an environment in we can do some coding, and we can do a lot of mathematical exercises here, right? So what I'm going to do here, I'm going to like deform the points of this geometry. So the thing how this kind of mountain component works is by basically grabbing one point and moving it to through the space using a noise information. In this case, we can have more control over it. This is the input tab. This is the output tab. So we have information as inputs. We will have information as output. Okay, this is how bobs work by default. So here, if we type noise, for example, we have a lot of components that are based on noise, a lot of them. The one that I'm going to use, it's called periodic whirly noise. Okay. This is more like using Voronoi in a way. So this is very straightforward. What I'm going to do here is I'm going to connect position to position because I want to grab all the positions of the points, and I want to deform them in a space using this information. And then I'm going to use that information, that new information, in order to displace those points in space. So to do that, I'm going to use the displace along normal. Okay, this is more like an offset component. Okay, so if I, for example, connect this position to the position displacement and then the displaced position to the output, by default, you will see that nothing is happening. But if I increase the displacement amount, you will see that my geometry will start being extruded, or this is more like an offset, as you may see here. Okay, so if you want to do an offset, this is a good way to control the offset. But what I wanna do is I wanna control this displacement amount based on this whirly noise. So if I connect, let's use the distance one to the amount, you will see that now my geometry is being deformed based on this data. That means that if we go inside this whirly noise component, I have the possibility to change frequencies here. So as you may see here, this is super similar to the mountain SOP. But in this case, by doing this process, we will have more control over the deformation of the mesh. Okay. So this particular component has these parameters that are called periods, so we can change parts of this noise. That's why I love to work with this particular noise. Okay, because we have the possibility to change parts of it depending on its direction. So what I did here in order to have a little bit more control over this geometry, it's to multiply whatever value I have here to another number I can have more control of. So what I'm going to do is I'm going to use a multiplied node here. And what I'm going to do is I'm going to connect this value to this. By default, I'm multiplying this with 1. So as a second input, I want to have a slider, okay? Or something similar to a slider in order to like multiply this value to make it bigger or not. So as we don't have sliders here in the attribute Bob, we have two components that are very similar to a slider for those who comes from Grasshopper. The first one is called constant. So from here, we can set a value here, or the one that I'm going to use, it's called parameter. Parameter, it's more like an empty component from where we can create our inputs as we want. So what I'm going to do here is I'm going to connect this parameter into input number 2. This parameter, what this parameter does as default, it creates a parameter in an upper level. So if I go back, if I press U, we will see that now in our parameters tab, we have this parameter slider, if I call it that way, that is doing something. That means that inside here, this is multiplying the value of the whirly noise with a number that I am deciding. So this is more like a multiplier. We can decide the minimum and maximum. I want the maximum to be 2, for example. Now, if I go back pressing U, I have the possibility to change the multiplier from 0 to 2. Okay, and this is cool. This is something that I really want to do. Let's go inside here. And let's focus a little bit on the whirly noise. What if I want to have control over the parameters of the whirly noise or any kind of component here? If I go back, you will see the only parameter that I have available here is the multiplier. But what if I want to change, for example, the frequency of the noise? Is there a way to import the parameters here? And the answer is yes. So what I'm going to do is I'm going to export all those parameters to the upper level in order to have more control over them on this particular level. The way to do it, it's just by clicking on this engine at the end and clicking on the promote parameter. If I click on each one of them, you will see that now my parameter is locked. It's because in the upper level, I have it here. So from this point, I can change it like that. This is something that I usually do because as I normally animate my values, it's better to animate it from this level. There is no way to animate something that is inside a bob. For some reason, I don't know why. Okay, and maybe let's call this scatter in 4 points for now in order to make it three-dimensional. And let's go back. So the good thing about this is now I have the possibility to control the multiplier, all the frequencies in detail. So I have the possibility to change the frequency, the offset, in order if I want them to move, for example, if I want to animate, I can move the offset very smoothly like that. I have the possibility to change the Voronoi type. I'm going to use Manhattan. This is the one that I like a lot. And I have the possibility to change like parts of the model like that. Cool. So basically, the values that I use are more or less like that. I use 2 here, 2.5. I am just reading my notes because those are the values that I use. And offset I put 1.2, 0.1. You can copy mine if my values if you want. If not, you can play with your own. So there is no limits here, by the way. So this is more or less the object that I got. So the next thing is I need to change the topology. So there are several ways to change the topology in Houdini. The first one is by using the classic remesh node. So what I'm going to do here is I'm going to connect it. By default, it will change my geometry using triangles, which is okay. I'm going to iterate a little bit more in order to make it more smoother. And the target size, I'm going to use 0.75 in order to have bigger triangles. What I'm going to do next is I'm going to use a node that is called divide. This division component, what it does is if you have a quad, it converts it into triangles. The thing is that as the remesh node creates the triangle by default, the division node is doing nothing. But the reason why I'm using the divide node is because the type of pattern that I'm using here is not based on a regular triangular topology. It's more based on n-gons of an n-gons topology. So the way to create that kind of n-gons is by using this parameter that is called compute dual, like that. So basically, what compute dual does, it finds like the center of each triangle and joins it, creating new polygons. Okay, this is what the compute dual does. Okay, this is a very fast way to create n-gons. Let me clear all my drawings. I'm going to activate this, and voila. The thing is that if I change, for example, if I change the frequency or the period in the attribute Bob, all my process will be updated immediately, okay? Even the retopolization. So let's keep it like that, for example. Great. So what I need to do here and what I did here in order to create this kind of separations or this kind of weird forms, it's by splitting the mesh. So for example, what I did here is, let me turn this off. Okay. So what I did here is I start splitting the mesh. Okay. So I splitted the mesh basically depending on its deformation. So what I need to do if I want to split something based on a deformation, we need to analyze the mesh. Okay. And that's something you can do in softwares like Grasshopper, softwares like Maya, which is analyze the mesh. In this case, I also can analyze the mesh. What I'm going to analyze or what I'm going to measure, it's the curvature of the mesh. In this case, this component, it's set on primitive, which is okay. I want to measure the curvature. Let's use the mean algorithm. If we try to see something, nothing is happening. But if we click on this eye icon, what we are doing is we are creating a new attribute. So basically here, let me type eye. Let me see. Oh, I cannot annotate. Let me do something very quickly. Okay, anyway, I cannot make even a screenshot. Anyway, what's happening here, basically, it's we are creating attributes. So by default, the only attribute that is available in my object is P from position. So basically, the only data we have is the position of each point in space. But now I'm creating a new attribute, which is called curvature. And this particular value, if I click on it, we will see colors. Those colors are data. That data is stored not on the points, not on the vertex, but on the primitives. Why? Because my component here, it says that it's analyzing the primitive of my geometry. Those numbers are data we can use for something later, right? I'm going to click again on the eye and click on the curvature because I don't want to see those colors. And then what I'm going to do is I'm going to split this geometry, but the component that I want to use, it's called vertex split. This is the component that I want to use. The thing is, this is vertex. This component works in the vertex level, and this component has the attribute on the primitive level. And I don't want, so I need to change or to take this, the values that are stored on this primitive level, and I need to move it to the vertex level. This action to take or to grab an attribute from a level, for example, from primitives, and move it to another level, in this case vertex, is something that it's called here promote. In Houdini, this is called promote or promotion, however you want to call it. So I need to promote an attribute. So the component is called attribute. If you type attribute in the search bar, you will see all the attributes components that are available here. The one we need is promote. The attribute promote component can take any kind of attribute and move it from one level to another level. In this case, I want to promote the curvature analysis, but for some reason I cannot see it. It's because I need to go back to the measure component and define and says, I want to use the curvature attribute. By default, this is activated, okay. And from here, I cannot see it for some reason. Oh, okay. It's because I'm expecting to analyze attributes on the point level. I need to analyze attributes on the primitive level. Now we're going to see it. Curvature. I want to move this curvature attribute from primitives to vertex. So by default, nothing is changing in the viewport because we are not changing the model itself. We are changing the data of the model. So if I click on the information button again, we will see that now my curvature attribute is on the vertex level. And this is what I need in order to use this component. I'm going to click on it. I'm going to join it. I'm going to grab those two. I'm going to make a group here. Okay. I'm going to change it to red in order not to touch this. Please do not touch this. And now we are in the vertex split. So what I did here is I need to define that I want to split this mesh depending on the curvature. So we need to call back again this attribute here in the attribute tab. By default, we are defining that I want to split something based on the normals, but we didn't define any normal here. So I'm going to click on this curvature. I'm going to delete the end. And now something is going to happen here. If you see very carefully, once I start moving this tolerance, something is happening on my mesh. So basically, it's splitting the mesh. So the smaller the tolerance, the more fragmented my mesh is going to be. Okay. So let's keep this into 0.1. I think 0.1, which is the default value. And what I'm going to do is I'm going to extrude the mesh. Okay. Let's use the poly extrude. So from here, I'm going to use the point normals. And let's see what's happened if I move the distance. My mesh, it's being extruded, but depending on the fracture. So if I, for example, if I increase this tolerance, we will see that my mesh will start working as it's just one whole mesh. If I reduce the tolerance, all my polygons will be independent because I'm fracturing everything. Okay, this is how you control the fracture of a mesh. Okay, I'm gonna put 0.1. Keep in mind that I have the possibility to change values here and everything is gonna change. That's the power of iteration. Now let's go back. Let's go down here. I'm gonna extrude it just 0.1 now. And down here we have in this, let me close this. In the spine control, we have this thickness scale. If I reduce it a little bit, our extrusion will be more tapered. Okay, so I'm gonna use here 0.9, like that. No, I think it's too much. Let's keep it into 0.98. I think it's okay. So now what I want to do here, in order to get this kind of detail, we need to do two different extrusions. One for the main geometry and the second for the detail. Okay, so what I need to do is I need to make another poly extrusion. So we can do two extrusions in like that. So the thing is that if I increase this second extrusion, everything is going to be extruded. And I don't want this to happen. What I want is I want to extrude only the top faces of each polygon. So I need to go back here. And if you see here in the extrusion tab, we have groups. This is another way to control objects in Houdini by grouping things. So here what I did is we have an output front here. If I turn this off, probably all my top faces will disappear. If I turn this on, they will be appearing. The thing is that I can create groups. So if I turn this on, I am defining that I have all the output fronts, all the fronts are grouped by using this name. I can put any name I want here. But by default, it's okay. So the thing is, if I go to the next component, I can extrude everything, or I can extrude only the group that I create previously, which is extrude front. If I click on it, only the fronts will be extruded, not everything, just all the fronts. And this is what I need, because what I'm going to do here, if I see in detail here, I want to extrude the front face just a little bit, maybe 0.01, almost nothing. I want this small amount to be extruded because the next step will be the subdivision. This subdivision use Catmull-Clark by default. I'm going to increase to 3. And this is how I obtain this smoother mesh. If I turn this component off by clicking on this yellow arrow, you will see that I start losing the crease on my mesh. If I turn this off, this is how I can control my crease. And now my geometry start looking more like those particular objects, as you may see. Okay, so now let's continue. Then what I'm going to do is I'm going to color my borders. Okay, this is something that I do as an exercise. So let's try to change a little bit the object. One of them are okay. Let's do it like that. I really like this one. Any of them could work, honestly. So what I'm going to do here is I'm going to try to paint the colors, because I can also work with the color attributes. What I'm going to do is I'm going to use a group node. If you type group on the search bar, you'll see again, we have a lot of components that are based on groups, okay? Because this is another way to control Houdini, by grouping. I'm going to use the group node, the first one. If I turn this on, you will see that by default, everything is being grouped. But I don't want everything to be grouped. What I want to do is I want to group all the borders, because what I want to do is I want to paint them black, because on a later stage, I want to manipulate. So for example, if I paint this, for example, black, and the rest is white, what I can do later in an attribute Bob, I could say to Houdini, just transform whatever is white and not black. So everything is black. It's not gonna be deformed, but whatever is white or whatever it's near white could be transformed. This is something we can also do, and this is something we need to do. So what I'm gonna do is I'm gonna group the borders. I'm gonna change the name this to border. In this case, I wanna select the points, not the primitives itself. And then instead of selecting the base group, I'm gonna go to the include by edges, click on it, and click on unshare edges. This will group all the borders, just the borders that are not attached to another mesh, which is great. Then I want to expand those borders till a point that more or less it reach this area here. So the way to do it is by using the group expand component, this one. By default, it's selecting everything. I don't want this component to select everything. I just want to select whatever it was grouped on the previous component. So I need to look for the border base group. And then we have this step tab in where we can increase the expansion like that. So let's use, I think I use 15, more or less like that. Cool. And then we can say, let's use a color node, and then we can define the color based on this group. So if I say, for example, I want you to, I can change any color here, for example. I could put blue, magenta if I want. But the thing is, if I want to paint only whatever I grouped previously, I need to define that the group I want to work is the previous group. It's not border in this case, is the previous one, which is called group expand. How I know it? It's because here the group name is called group expand. If I want, I can put the same name just to keep my system organized. If I go to border, now just the border that were previously grouped is gonna be painted like that. In this case, for my convenience, it's better to keep them black like that, because I'm gonna use those values to deform only whatever is white, right? So then if you consider this border it's too sharp, we can blur it by using an attribute blur. We can blur data. We can create average numbers here. In this case, by default, it's blurring the position. So basically, what this is doing by default, it's smoothing the mesh, but I don't want this to happen. I want to blur just the color. So the default attribute name for color is CD. So if I change this P to CD, we are gonna smooth the colors like that. Great. Just like that. 15, it's okay. And then again, now that I've created my color attributes, I'm gonna go back and use another attribute Bob. This one as well. This is gonna be called, let's call it smooth by color. Let's call it like that. And let's go inside. So what I want to do is I want to transform only the polygons that are white. So the whiter the color, the more deformed it could be. Okay, so if I, for example, use the displace node, this is the node that I'm going to use, and I connect it here. Again, if I move the displacement, everything is going to be displaced, but I want just only displace polygons that are white or polygons that are near white. So that means now we need to use another attribute. Here I'm using the position attribute, but we also have the possibility to take advantage of the CD or the color attribute. So if I use a multiplied node, for example, and if I connect it here, and I use this value into the amount here, you will see that only the polygons that are white are being displaced, but not the rest. So that means if I, for example, grab a parameter node here, and I connect it, not there, but I connect it into the input number 2, let's call this multiplier again. From 0 to 1 is okay. So if I go back, for example, if I move the multiplier, you will see that only the wider polygons are being displaced. But in this particular case, I don't want this number to go positive. I want this number to go negative. So if I go back, I have the possibility to change the range, or I can use a negate component, or this is negative in Grasshopper, and just that. We go back, we change the multiplier, but this time is going the opposite, inwards, like that. Great. So let's keep this into 0.1. It's more like deflating the mesh, and I really like this. It's really cool. Great. So next step is what I did here. We are in a good spot here. So what I did here now is I separated the bigger polygons from the smaller one. So in order to make that split, I use a component that is called delete, but the one that is using labs. Keep in mind that if you want to use this component, if you type labs in the search bar, you will see that there are a lot of components. Let me click on this as well. Oops. Okay. You will see a lot of components that starts with labs. Labs, it's basically a plugin for Houdini. If you don't have any labs component, be sure to install it. By default, once you install Houdini, during the installation, you have the possibility to select if you want to decide if you want to install this plugin. I highly suggest you install labs, because a lot of hard surface modeling, or in general modeling objects process we do, we need labs components. Okay, so I'm going to use some of labs components. In this case, I'm using this delete small part component. In this case, I'm going to separate my objects based on their area. In this case, I'm going to click here to extract larger piece. So this is extracting the largest bits. So I'm going to make two different workflows, one for the largest and another one for the smallest. So in this case, the way to make a separation here or a differentiation here is by clicking on the invert results on the second. So here I have like the smallest and the biggest, okay? So let's make it the opposite. Let's work with this, the biggest first. Okay. So what I'm going to do now, it's now that I separated the biggest from the smallest, I'm gonna color it again, completely white. Okay, which I think is great. And then we're gonna do something. We're gonna use a symmetrize node. This is again from labs. Okay, and in this case, the way how symmetry works, because this is quite tricky. If we, for example, put by default, let me explain you this. By default, I know this first column belongs to X, this second to Y, this third to Z. And if for some reason you see a fourth column here, this stands for time, okay? Because there are some components that change three-dimensional, you can change three-dimensional objects, but there are some that could change fourth-dimensional objects, which is basically time. So in this case, what this is saying is that we are creating a mirror, or if I can say that way, in the y-axis, so three-dimensional. So basically, it's copying the object this direction. So if I want to copy like from this direction, which is x, because I want to do this, I want to do this symmetry. So if I move my object like that, I want my object to be copied like that. So I want this symmetrized. So basically, my axis is this one, but the way how it's symmetrized is like that. So basically, I need to define x. I need to define x as the symmetrized axis. So in this case, I want to put in the mirror direction 1, and this is 0. Okay. That's how symmetrized works in Houdini, which is quite a bit different than other softwares. This works like that. Then I'm going to use subdivide in order to make it smoother. Okay. Great. But for example, let's imagine I wanna make those creases a little bit smoother. We can use several components here. We can use an attribute blur. This is one alternative. Just by smoothing, by smoothing the position, you will see that we start smoothing our mesh. There's another component that is called delta mush. I like this more. This is another one. Just keep in mind that in this case, we need to turn the pin. We need to check the pin border points in order all the borders not to move. So like that. And there is another one that is called, I think, smooth. This one as well. So we have like those three components. Okay. I don't think. Oh yeah, this is working. This is even smoother. Okay. So I am not going to use those. I'm going to keep delta mush. This is the one that I like the most. Let's keep this into 50, for example, to make it smoother. I really like this value. Great. And basically, that's all. We don't need to do more. In the file that I sent you, this process is quite a bit longer, but I think this is more than enough. The thing is, I want to repeat this exact same process for the smallest objects. So first, I can copy the color. For example, this, I want this to be, I don't know, like that. So instead of copying this to the side, the thing is, let's imagine I copy those three. For obvious reasons, it's they're gonna work. So if I click on this, it's gonna work. If I click on this, they're gonna work. The thing is that what if I change something on any of those components and I want that data to be transferred to this second method? The thing is, if I copy paste it, I will need to check it manually later. And that's something I don't want to do. So there's another way to keep the logic of those components in a copy. It's by right-clicking on them, actions, and create reference copy. If I do this new component will have this information down here that it says reference from symmetrize one, which is basically copying all the data from the previous component, which is this one. If I change something here, the value on the other component will be changed as well, because all of them have this this expression that is basically saying that it's repeating whatever is happening on the component one. So I'm going to change this color to green in order to be sure that this is a copy. So I'm going to repeat this process with the rest of them. This is something that I usually do in order not to double check later things, something like that. Yes, so I have first one, second one. So that means if I go to the first component and if I change, for example, the iterations to 0, in the second component, the iterations will be 0 as well. So it's like creating blocks, or components. I think in Rhino it's called block or instances. It's like creating instances here. Once I'm happy with it, I can grab both of them. I can put merge. And that's everything. So I have my symmetrized object. If I go back to where is my noise deform, here, if I just change the periods, I will change my object like that. Very simple. This is the power of iteration. Now I'm happy with it. All of them looks nice. So let's go back here. And there is something missing here. In our exercise, we have this kind of goldish exoskeleton here. So I'm going to create it right now. I'm going to create another workflow here, which starts from here. What I'm going to do here is I'm going to extract all the borders of the polygons. So the way to do it is by grouping something. By grouping, let's call it exoborder, right? Let's use another name. In this case, I'm going to select edges, but not all the edges. I want to group the edges based on the previous split. So that means now that this new mesh is splitted, I know that I can go to the include by edges and unshare edges. So the group is going to be different. So basically I'm grouping all the polygons that are separated from each other like that. This is great. This is what I want. Then I'm going to extract those borders by using extract border. What is my extract border? Oh, let's type border. Oh, this one. Extract border. Okay. This is literally extracting the border like that. Then I'm gonna fuse them in order to be sure that they are joined. And next, I'm gonna convert the lines to a tube by using polywire like that. I'm gonna reduce this to 0.3. This is the value that I use. And I'm gonna reduce the divisions to 3. So they are basically triangles, but I think it's fine. I like this. Then in order to make them smoother, subdivision. So the more subdivides, the more I subdivide the mesh, the smoother it's gonna be. So I think I use 4 in this case. If you wanna control the crease, you can activate the override crease. So the more you override, the more like polygonal it would look. So let's keep it more or less like that. 0.6 is okay. I like it. Looks really cool. And again, you have the possibility to smooth a little bit more by using Delta Mush. This is something that I use. So I can increase this value to make it smoother just a little bit, not too much. Even less, I guess. And that's great. So the thing is that now I need to copy Let's put this somewhere here. Let's move it somewhere here. I need to copy all of them, all of this process because I want, first I need to paint it gold. Let's make it gold like that. Then I need to copy this process. I can copy paste this one because as this is just reference for, it's reference from the previous first components, I just copy paste. So the process is being repeated. And that's all. I cannot see the structure because it's quite a bit far. So what I can do is I can expand them a little bit by using the pick node. I'm going to put it here just a little bit. No, it's too much. Quite a bit, maybe even less. But maybe I can use the transform node and make it bigger a little bit. Just like that. Great. Or if I want to have more control over the expansion, click on the viewport, press enter, and we have the scale option here. We can scale it manually like that. So this whole new information, it's been edited in the parameters. So next time I made an iteration, so let's go back to the iteration here. Each time I change values here, this expansion attribute will be also updated like that. Great. Nice. I like them. Cool. This is basically what I did. So finally, in order to finish this part, so what I did here is from this point onward, let's save the file first. Let's get a new folder. This is going to be called Methodic Exuberance 2.0 accept, and this is going to be called exercise 1. Great. Okay, so when we can do next is we can start transforming the mesh, by the way. So each time we can like interact with Houdini this way by changing numerical values, by changing just simple data. But other way to interact with the mesh, as I said, it's manually. It's by editing it manually. So if we type, let's see, no, let's type taper. Yeah. We have some deformation components like taper, twist, bend, the same as other softwares. So the thing is that, for example, I'm going to do a linear tape, right? If I click on it, you will see that by default, I cannot see anything. I can see nothing on the viewport, but I have a lot of information here. If I try to tweak them, we will see that something is going to happen in the viewport, but probably I don't have so much control over it. You will see. So let's go back. I think it was in 0. No, let's do it again. Taper, right. But then down here we have the capture tab. And even if you click on it, you will see that something is happening in the viewport, but I don't know what to do. I see just those numbers floating around the viewport, and this is going to be very tricky. The thing is that we need to set the capture region, that basically it's telling Houdini that I want to deform something that is inside this bounding box. Okay. This is something that we usually do by using the capture region, but it's quite a bit tricky to use. So instead, I found another method that is working manually. So as I said, if you click on the component and you click on the viewport and you press enter, you will see in this particular case, this information. Okay. Keep in mind that now, if you try to orbit, you're not gonna, I mean, by default, you're not gonna orbit unless you press Alt and left click. Okay. If you press Alt, you will activate the camera, and by left click, you will orbit. Keep that in mind. In this case, now that we have the viewport activated, now we have those buttons here, F, G, H, B, and M. Those are basically shortcuts. The first one we need to use is the one that is called fit capture. So as you may see here now, the bounding box is smaller than the object. If I press N in the keyboard, I will make my object to fit this bounding box, and now all the values that used to be in the capture parameter are updated. Then, for example, what I want to do is I want to make, let's imagine this is like the back part and this is the front side. I want the back part to be smaller. So I need this, like this plane to be at the back. So if I want to rotate this, I need to reverse capture, M, like that. If I want to rotate this plane, we have cycle capture. If I press B, this plane will be rotated. Okay? So if I can do something like that, for example, I can make this even smaller, or I can rotate it. So I want this to be bigger, maybe. This smaller, like that. So let's imagine I'm creating like a vehicle, for example. I don't know, something like that. This is when the scale now it's important. When I make something like that, maybe I can move it somewhere there, like that. Great. So I can create another taper node, for example. And this second taper node, I'm going to press again N. Then I can like make this smaller, like that, maybe. And maybe what I can do here is I can go back to the capture and manually I can move it upwards like that, for example. Okay, this is how I would interact manually in Houdini. Now I can click on, I can create a null node, which basically it's my out component in order to keep the viewport clean. So basically, this is how I create an object, and I can go back to the attribute Bob. I can still change. I can iterate. So if I put it somewhere there, let me turn polygons off. But let's keep it like that. I don't know. I have the possibility to change values here. So each time I change those values, I can iterate my object, right? So I can change this manually, as you may see here. So if I put like, for example, 50, it's going to work. But there is another funny way to change all of this. So for example, what if I want to change something based on the timeline? That is something that I usually do. So each frame here represents a different iteration here. The way to do it is by linking one of those values to the timeline. So the way to do it is by saying, let's edit, for example, the offset in Y. So if I move this value, my iteration is going to change, okay? I have a new iteration. So the way to link one parameter to the timeline, it's basically by using this expression, the dollar symbol and FF, okay? This is universal, by the way. So there are a lot of expressions in Houdini. A lot of expressions starts with the dollar symbol. And I have the link here, by the way. And I put this link. Let me copy this to the chat. Okay. And let me open it next to it. When using Houdini, something that you probably will do a lot is to read documentation. Okay. Basically, this particular documentation that is called parameter expressions have this part. Yes, this part here. In here, we have the possibility to learn all the expressions we have in the parameter level. So the one that I'm using is this one, because this is basically giving me the control over the parameter through the timeline. So basically the numbers that I'm going to get right now are related or linked to the timeline or to the frame number in this case. So that means that if my timeline is in the frame 1, my offset will be 1. If my timeline is in 31, my offset will be 31. That means if I press play, my timeline will start running each time I have a new frame. In consequence, I will have a new iteration. Okay. I think it's really cool because what I'm doing is I'm just creating iterations of the same, let's call it of the same procedure, but not object. So that means that I have the possibility later to automate Houdini and say each time you create a new frame, you can export this model because we can do it. That's something that we usually do using tasks. I'm not going to use tasks today, but for example, if you want to, let's imagine I want to export 240 objects. Can I do it? Yes. The way to do it, it's by automating Houdini and using tops and saying it each time we create a new frame, export each frame as an OBJ. That's something we can do. Okay. But for now, let's keep it like that. Okay. For now, this is everything we need to do on this first exercise. This is just to warming up, to get familiar with the software. Now let's go to the next one. Okay. Keep in mind, if you have any questions, you can use the Q&A chat. If not, I can continue. So let's talk about this second exercise. By the way, these particular images were rendered using not Karma, but using a simpler render engine here in Houdini. I can teach you how to do this later, but for now, let's keep this into like that. Just keep in mind, we have another way to import materials, right? So, for example, in this case, let me show you something very quickly. That's something that I normally use. Let me organize my board, maybe here. For example, what I did here is I apply just a base color, a white color, but we have the possibility to import textures in a way, very quickly. There is one component that is called quick material, okay? If I turn this off and I put the quick material here, by default, nothing will happen. But here on the parameters, up here, we have this material type set in default, which is called principled shader, but I can change it to MatCap. Okay. MatCap are these kind of textures in where we store not only color information, but light information, reflective information, and so on. And if you want me to share this particular file, I can do it. Keep in mind that I shared another link, which is this one. On here, you will find this particular exercise, which is more complex. But if you want me to share this second version, I can do it during the break. Worries. But I want to talk a little bit about the quick material component. As quick material works with, in this case, we selected the MatCap shader. So MatCaps are basically a type of textures that contains not only color information, it also contains reflection information, light information, and so on. And over the internet, there are some libraries and repositories where you can find this kind of materials for free. So let me see. I remember I put the link on the guide, but if not, let me find the name of this particular. Okay, it's called MatCap's Master. Okay, so what we can do here is we can look for MatCap's Master. If I remember correctly, this was a repository on GitHub. Let me see. I think let's see. I think it's this one. Yep, it's this one. I'm gonna share this in the chat, by the way. Okay, this is very cool. Let me put on the chat. Okay, so what I did here is I downloaded all those MatCaps. Okay, those are not just regular textures. This is something that you usually do in ZBrush. ZBrush works a lot with MatCaps. Okay, so that's how you see reflective or lights in the texture, because MatCaps contains that kind of data, not only color but reflective lights, shadows, and so on. So what I did is I downloaded that repository that I have it here, by the way. So those are based on sizes. So if I click on this one, for example, those are MatCaps. Okay, so I can use any of those MatCaps in order to apply those textures on my mesh. So for example, let's imagine I want to use, for example, this one, the one that is called, well, it has this weird name. I'm gonna press Control C, because the names are quite hard to learn by memory. So if I click on this quick material component, I have the MatCap texture. So here I need to look for the material. So let's do something very quickly. I'm gonna copy some of them on my desktop to the M2 here. Just to test it out, I'm gonna click on the MatCap texture, this search icon. I'm gonna go to the desktop, M2, and I can select any of those. Let's select the first one. So the color will be applied. The thing is that this is multiplied by the previous color. So my previous color used to have this gradient. So this new quick MatCap material, it's multiplying with the previous color. So if I turn this on, if I create a white color, so I can get rid of that gradient here. So I can change it, for example, to this one, and that's better. Even the reflection can be seen here. That's the cool thing of using MatCaps. Okay. Let me see if I can change to another color. Okay, this is a good one. Right. So let's go up to the final, and we will see something like that. Okay. The more time you invest on it, probably the cooler materials you will find. And this is how I made this type of renders. What is it? Here. Those are just MatCaps. Okay. But not the lights. Those red and blue accents were made by using area lights here. Great. So now I am going back by pressing U. Keep in mind, if I want to go back, I can click on this jump back arrow or just pressing U in the keyboard. I don't want to see this model anymore. I'm going to turn this off, and then I'm going to focus on the object number 2. After this exercise, we're going to make a 10 minutes break, and I'm going to share this particular file in the chat. So no worries for those who wants the file. I'm going to share it in the chat later. It's fine. So let me see my notes. Great. So I'm going to save my file. Let's go to presentation, and let's focus on this. This particular exercise is based on grouping. So the more control we have over grouping, the better this exercise will work. So here, basically, we are scattering points in space, we are grouping points in space, and we are just finding the shortest path between points in space. This is a very straightforward exercise, but in Houdini, it gets quite tricky as we need to learn how to group things, okay? So you more or less know how to group things because in the first exercise, we did some grouping workflows, but now let's focus more on the group itself. So first of all, I need to scatter points in space. So in this case, and this is something that works very similar in Grasshopper, when you need to scatter points, if you want to grab like some points and scatter in space, first you need to have like a reference object. So for example, in Grasshopper, if you have a plane, you can scatter points in the plane. There is no difference in Houdini. That's something that works in Houdini. And then if you wanted to scatter points in the volume, you created the volume and scatter points in the volume. That's the same in Houdini. Just the components' name are quite a bit different. So what I'm going to do is I want to scatter points on a volume, okay, on a box, not on a plane. So the first thing I need is the reference geometry. Okay, so just a very regular cube. Okay, nothing new about this. I'm going to use this box as a reference. So then I can scatter points. The component that I'm going to, if you put a scatter, we have a scatter component. The thing with the scatter component is that it only scatters points on the faces of the cube. But I don't want this to happen. I want to scatter points inside the volume, 3-dimensionally. Okay, in this case, the scatter component won't help me. Okay, for this, at least not for what I want to do right now. The solution is by using points from volume. This is the one. By default, we will see a very regular grid happening inside the volume. It's okay. So what I'm going to do here is the only value that I'm going to change First, I'm going to change jitter. Okay, the more I change this, the more this grid is going to change. But this is not changing because of the scale, jitter scale. So if I move this, everything is going to change. The more I change this value, or the higher the value, the more heterogeneous the grid will be. But I don't want this grid to be so heterogeneous. I just want a little bit. I just want to break the regularity of this grid just by defining a very small number. Just that. Okay. Even a little bit more like that. That's more than enough. Then I can change scale, the seed. We can make the separation a little bit bigger, but let's keep it by default. Okay, I'm gonna keep this into 0.01, just that. Then the next step is to connect everything from here, because I want all the points to be connected. On this particular exercise, what I'm doing is I'm connecting points. So there are some points that are here, and there are other points that are there. So that means that I need to join them in a way. So what I'm doing is I'm joining points or connecting points, or basically connect adjacent pieces. Okay. This is the component we're going to use. Let me check. Yeah. So in this case, what I'm going to do is I am not going to connect pieces from points, but I'm going to connect the points itself, right? So let's see. Let's use a very small number. For example, like that. Just give me a second, guys, because something is calling me. I'm going to turn my cell phone off for now. Cool. Okay, so I'm just gonna, the more I increase this value, I am gonna create those kind of lines, because what I'm doing here is I'm creating more like a threshold in order to connect elements like that. Okay, if I use, for example, a very small number like 0.8, even less, I guess, 0.5, you will see that my connector is gonna be like orthogonal, right? Cool. But again, this is not the type of connection I want. So probably here, I will need to change something. Now, for now, it's okay. So let's continue. Let's continue. Probably here, I can increase this a little bit more like that in order to have not only orthogonal connections, but this kind of diagonal 45 degrees connection. Great. So basically, I'm creating all the possible connections here. So then I'm going to do something very interesting. From this grid, I want to define some initial points, maybe here. So I want Houdini just to use the points that are set here. And maybe I want them to be connecting with other group of points that are more or less here. I don't want to create all the connections possible, but I just want to define the points that will take part on this connection thing. So I need to group points, okay? So what I'm going to do here is I'm going to create a group component. I'm going to connect this into the first one and turn it on. By default, it's grouping everything, but I don't want to group everything. By default, it's grouping primitives. I don't want to group primitive. I want to group points. By default, it's grouping all the points, but I don't want to group all the points. This is going to be called the start. Okay, I want to call them start. So basically, I'm going to create a workflow for the starting points. So how can I get control over the grouping thing manually, as I said? Well, we have this second option that is called keep in bounding regions. If I turn this on and I change the bounding type to, for example, object or volume, in this case, I'm going to go for object. We will see that something is happening. Let me read. Okay, here it says not enough source specified. What I'm trying to define here is that I can create a grouping region based on an object that I can model manually. If I don't have an object, I can use either bounding box or bounding sphere. If I click on bounding sphere, And if I press enter on the viewport, we will see this kind of sphere or ellipse that I can tweak it manually in order to move it, for example. So by moving it, I'm grouping. Or I can create this object literally or I can define it explicitly here in Houdini using this second input, the bounding object. So what I'm going to do is I'm going to create that sphere. Okay. This is going to be called bounding objects. Okay. Bounding object. Great. So by default, let me see. Let me save the file. Okay. So by default, this object is okay. It's this size. It's great. So this is my object here. So I'm going to use the transform node, not trace again. Transform node in order to have control over basically the scale of the object. This is basically what I want, to have control over the object. So basically what I'm going to do here, let's keep this into 1, 1, and I'm going to control it using the scale. Maybe 0.6 is okay. And I'm going to connect it to the second input. And I'm going to change the bounding type to bounding object. So basically I have my object there. If I want to move it, I'm going to click on the transform node. I'm going to press enter on the viewport. I need to change this to move. And I have the possibility to move this. So basically I'm moving my object in Houdini and I'm grouping this. So I'm going to turn this off. Okay, now I can move it. Okay. So keep in mind, by default, I have a sphere as a bounding volume, but I can use another type of object. So for example, if I type the test component here, I have our lovely piggy head, the classic piggy head that is being used a lot in Houdini. So if I copy this component and I connect it here, instead of grouping with or using instead of grouping using a sphere, I'm grouping using the piggy head. And that's something you can do as well. You can use any type of volume in order to group things here in Houdini. I'm going to use the sphere for now because I think it's okay. So let's try to put this sphere in one of the borders. I think this is okay. I'm going to keep this smaller like that. Okay, let's put it somewhere there. And those are my starting points, right? So now I'm going to create another workflow for the ending points. So instead of using one sphere for the ending points, I'm going to do something more interesting. I'm going to create another component, another sphere component. Okay. In this case, I'm going to make this smaller, like 0.5. I'm going to save it. And I'm going to show you something very cool. In this particular case, okay, I have this regular sphere. It doesn't matter the topology. But what I'm going to do here is I'm going to scatter some points. Okay, I'm going to scatter some points all along the mesh, on the surface of the mesh. So, but not that much, maybe 20, like that. So basically, those points are being scattered on the mesh. What I want to do is I want Houdini to copy the exact same object, this exact same object, on the points that I already created. So in order to do that, we have a component that is called copy to points. So copy to points has two inputs, one that is called required geometry and target points. So basically, in this first input, I need to define that I want to copy this sphere on the points that I already created. So I will have something like that. Okay. If I go back to scatter, I can increase or decrease the amount of spheres. So it looks like our sphere is doing mitosis, something like that. I can change the seed to change or to find another iteration. But the reason why I'm doing this is because I want to show you another type of attribute we can change. So as I said, in Houdini, there are a lot of attributes we can modify. So even if we don't see more attributes here, for example, here we have the scatter points. If I click on the information, I see this P attribute that stands for position. And here it says three float. That basically means that this position attribute is made by a three float value. So there are three values. So basically, position X, position Y, position Z. The thing is, I have the possibility to create more attributes, or to import more attributes. There are a lot of attributes going on in Houdini. Even though they are off, I can like import them, and one of them is the scale. I can change the scale of this element or those elements randomly. What I'm going to do is I'm going to use a component that is called attribute randomize, because I can randomize values. In this case, by default, you will see that once you place a randomized attribute here, or attribute randomize, sorry, you will see that by default, we start obtaining this kind of random colors. Because by default, what this component does is randomize colors. So here in the options, you have seed, then you change color. But I don't want to change colors. What I want to change is scale, the scale of the objects. So I need to change that attribute. And the attribute name for scaling objects, it's called pscale. That's the attribute. Okay, that's the name. If you read Houdini's documentation, you will find that the attribute that changes scale, it's called pscale. You have another one that is called scale. Okay, but the reason why I don't use a scale, it's because the scale attribute requires from me to have control over X, Y, and Z independently. That's why I obtain this kind of ellipses. The difference between the scale and pscale is that the attribute pscale change the size of any object homogeneously. So X, Y, and Z is the same. So from here, what I did is let's go to distribution. I use the uniform distribution mode as default, which is okay. I just need to set the minimum and maximum value. So what I'm saying here is that the minimum value could be 0. I don't want anything to be 0. I want the minimum or the maximum to be 1.15 and the other one 37. So basically what I have here are elements that are scaled from 0.37 to 1.15. Just that I can change the size of it. So now I can use this new object as a bounding object. Even before doing it, I'm gonna use transform node again, just to have the possibility to change a scale. So I have this possibility to make it smaller or bigger. Okay, I remember by default I make it smaller, and then I'm gonna move it. What I need to create now is another group based on this new bounding volume. So I'm going to create another group now. And I'm going to continue the logic from here. Okay. So in this case, this is going to be called end. Those are the ending points. Again, I'm going to select end. I'm going to go to bounding regions. This is going to be working with the bounding object. I'm going to connect it here. And now I have my other selection. Right. The only thing I need to do is I need to define the position. So if I'm using, for example, this is something that I did. If I just choose opposite. So if the starting points are based on this corner, the ending points are going to be placed somewhere here. Okay. I just decided to place them with this opposite logic. So that means that I need to grab this second object and I need to move it somewhere there, I think. More or less there. Cool. Nice. So now I have starting points, those in this first corner, ending points in the opposite corner. So now that I have two different groups, one for the starting points and another one for the ending points, I have the possibility to make new lines that can look for the shortest path between those points. those shortest path will be based on this existing grid that I already created. So Houdini is going to look for the shortest path on those lines. So then if I change the lines grid, the shortest path will change as well. So what I'm going to do is I'm going to look for find shortest path. This is the component we need. I'm going to save my file. By default, nothing is happening. If I see why it says, well, it says nothing because nothing is happening. So the thing is, the reason why nothing is happening, it's because I need to define what's the starting points and which one are the ending points. So here it says start points, end points. So my start points used to be called start. So I need to look for the name start and end points end. And something is happening. Basically, that's everything we need to do. So something is happening. If I want to iterate this connection, I need to go back either points from volume. I can change the seed, for example. Sorry, not the scale, but the seed. I can change the seed of the first grid, or I can change the scatter of the second object, like that. Great. If we want to make this grid to be more rigid, I move the scale to 0. So the higher the scale, the more organic this connection will be. So for example, this is one methodology to create linings. If you have ever seen linings animation, this is how you create it, like animating this scale like that. You know, this is like the basics of this kind of animation, but I'm using it to create structures like that. Okay, cool. So next thing, now that I have my structure, that looks really cool. Maybe what I can do here in the connect adjacent pieces, I can make the radius bigger or smaller. So the smaller you will see, the more orthogonal. But in this case, I think 0.09 is okay. I really like this particular structure. Cool. So next, I'm going to convert them into tubes. So again, we can use the poly wire node. This is one option. Oh, let's make it smaller. I think it's way too big. Maybe 0.01. Yeah, even less, I guess. Yes, like that. We can use, for example, this node, but I want to show you another node. We can use another node that is called sweep. Okay, the sweep node works similarly than the one we have in Rhino. Okay, it's very similar. So in this case, nothing is happening because this is waiting for me to include like the cross section or the profile. But I don't want to use a profile here. I just want to go to the surface shape here. And instead of using the second input cross section, I'm going to go to ribbon. This is going to create a ribbon. I'm going to reduce the amount of columns and I'm going to make this smaller, like maybe 0.06, I think was the number. Maybe a little bit more, 8, like that. So now I created ribbons. So then what I can do is I can give them some thickness by using the thicken node. This is another way to create volumes in Houdini. In this case, I think I use a very small amount of thicken, like that. Yeah, now they are more or less tubes with a little bit of difference between sizes, like that. I really like this profile. The reason why I made something like that, it's because here I want to show you a really cool method to convert these kind of orthogonal elements into more organic shapes without losing this kind of polygonal detail. So what I'm going to do is I'm going to like convert all these polygons in something that is called BTB, that are basically voxels. So what I'm going to do is I'm going to go to BTB. So BTB is this methodology that normally designers use to create clouds, fog, fire, stuff like that. So keep in mind the clouds, fire, and fog, they are not polygons, they are more BTBs. So we're going to use this logic to create something very interesting. So I'm going to go to BTB from polygons. So I'm going to grab all the polygons here. and convert them into VDB, right? So I'm gonna connect this, and we will see something like this happening. So what we are creating here are voxels. So keep in mind the voxels are this kind of agents that contain data. So they are not polygons. They are nothing. They are just voxels. If I click on the information button, we will see that now, when I used to have here certain amount of points, primitive and vertices, now I don't have them. I just have one in each one of those levels. But the thing is, if I go down here, we will see float voxels 949. That means that I have this amount of voxels with this size each. So the more voxels we have, the more information we can store on them. So in order to have more voxels, I need to reduce the amount of each voxel. So if I go, for example, to 0.01, my geometry will start looking more like the original one. But I think we need even more detail. So maybe 0.05. And that's more or less what we have here. Maybe a little bit less. Great. That's perfect. So now what I can do is I can convert them again into a geometry. But what I'm going to do is I'm going to smoother during this process. So the first thing that I do is I use a component that is called resample. Okay, it's like any type of resample component that you already know. Basically, this component gets rid of any unnecessary voxels. So probably I'm gonna have less. This is the previous amount, 177K, and probably here I will have less. So the less, in a way, the less voxels, the better. But I am just getting rid of some voxels that are unnecessary without losing my quality. Then I'm gonna use a component that is called VDB reshape. This one, reshape. So with this particular component, we have the possibility to inflate or dilate the road, open or close. So in this case, I'm gonna make some inflation, maybe 1.5, and then we are gonna I think we're gonna smoother a little bit. No, maybe I can do it a little bit more. Maybe 2, it's okay. And then I'm gonna convert it back to polygon. Convert VDB. So now I have the possibility to return it back to polygons. Now this is a continuous polygon, as you may see here. That's the idea, to have now a continuous mesh. But the thing is that now it feels like it's thicker. So what I can do is I can use my delta mush component, and I can increase this value maybe to 100. Yeah, maybe like that. And now I have this kind of a structure that looks more like a branch, a tree branch, something like that. Great. So other thing that I use here in order to make those unions, those joints less smoother, it's by using a node that is called sharpen. Okay. If I use sharpen, you will see that all my links or unions will start looking more like that. Maybe 500 is too much. I'm gonna reduce a little bit to 50 maybe. Yeah, like that. So this is smoother, this is sharper. Great. Now, again, if we go back to my original geometries, I can change seed here and all my system will change. I can change the seed of the second points and everything is going to change. Again, we can link this seed to the timeline by typing $FF. If once I press play, all my elements will change on each frame. So that's the goal of iterate, the power of iteration again. Okay, I'm going to keep this into 1. I really like it. And let's save my file. Great. So I use a component that is called match axis. For what I want, it's to make this horizontal. And I remember I changed the vector type like that in order to make it more horizontal. Probably this is not working properly. No, it's not working. Let's use a transform node. I just want to make it more horizontal. Maybe. maybe something like that. This is more manual. This is a more manual thing. So let's keep it more or less like that. I want it to look more horizontal. Okay, right. And basically that's my structure. So then here we have two options. We can start multiplying this mesh in order to make it more complex. So a good way to editing it, for example, is by using the copy and transform node. This is something that for those who are familiar with ZBrush, this is something that we do a lot in ZBrush, which is copying and transforming something. So basically, if I increase, for example, here the amount of copies, what I can do is I can press enter on the viewport and start moving it. For example, I can move it somewhere there. I can make it smaller, for example, like that. Did you see it? Like that. Maybe I can make it longer in a way. Then I can move it again. So as you may see here, I'm editing this object manually on the viewport, but not necessarily here through the parameters tab. Okay, and I think this is really cool to do something like that. Then if you want to go even crazier, let's copy again. Let's create another copy and transform node. And for example, here what I can do is instead of moving the previous object, I can maybe increase a little bit more this element, press enter, and maybe instead of displacing the object, I can rotate it, something like that. Maybe then I can move it, you know, maybe I can make it smaller on each rotation and something like that. I don't know, maybe something like that. The reason why I am showing you this is to show that you can interact manually inside Houdini. Not everything here it's done procedurally or computationally. We can interact manually. So I can change these values, for example, as much as we want. Okay. So keep in mind, the more you copy it, the slower your computer will be. So let's just keep this into just one for now. Again, we can use our quick material component just to apply some materials. We're using MatCap. Let's try to use one of the ones that I had. Okay. If you download this library, you will have a lot of options to choose from. Okay. And finally, I'm gonna use a null node just to define this as my output. Great. So this is basically our second exercise. I'm gonna go back here. Now from here, I have two objects, one in the same position as the other. So what I'm gonna do here is I'm gonna transform this second object, and I'm gonna put it next to the previous one. Let's make it bigger. Not that big, maybe somewhere there. Great. Cool. So basically, those are very simple exercises just to get familiar with Houdini. Now, with all that knowledge, now we can make our first step, creating patterns. In this case, we are going to import patterns using Midjourney. Okay, so we covered this second exercise. So now let's make a 10 minutes break. Okay, so for me, it's 12:20. So let's make a 10 minutes break. If you have any question, let's make a Q&A session, small short session after the break. So in the meantime, you can try to install MLOPs in the meantime. I'm going to be around, right? So I'm going to share this second file to you, just for you to check this shorter version of each exercise. Okay, I'm gonna do the next thing. As I don't want this this workflow to work each time you open the file, this is something that I do. I grab all my workflow, all the script, and I go to the first one. I click on this yellow icon. So that means I'm going to turn everything off. So each time you open the file, you will need to go manually and turn them on. Okay. This is basically to avoid my computer to run each time I open a file. This is something that I do. Other thing that I do to avoid my computer to crash is if I want to keep everything on, I can go to this button down here that says auto update and I change it to manual. By changing this to manual, it doesn't matter what you do here. If you change something, you are not going to be able to see the update. This kind of message will appear. Update mode is manual, view may be out of date. So that means that nothing is going to be shown. It means that even my script is on, anything is being computed. Unless I change it, unless I click on this refresh button or I change to auto update. Okay. So if you want to avoid computer crashing, you can save your file in manual mode. But what I normally do is I turn everything off. Okay. So I'm gonna save my file and let's take some 10 minutes break so I can grab a glass of water and I'm gonna stop sharing screen. I'm gonna turn my camera on. In the meantime, I'm gonna save the file. I'm gonna put it on the board on the chat as well, and see you in 10 minutes. Okay, see you then. Okay, I'm back. Cool. Let's continue. If you don't have questions, it's okay. Keep in mind you can ask later. You can send me messages later if you want. So as Pablina said in the chat, you will have the recordings later, in some days. So you can practice later. Don't forget to tag us when doing your own experiments. Don't forget to tag Design Morphine. Don't forget to tag me on your Instagram accounts. So we would like to see what you are what you are doing with our experiments as well. So I'm gonna share the screen again. Let's see. Cool. So before continuing, I'm gonna share. Where is the link? Let me look. Oh, here's the link. Okay, I'm gonna share this link again because in this particular file there are so many things going on. So let me look for my own files just to check. Just give me a second because I need to look for not this, but I think yeah. Okay, so in one of the folders of the link that I sent, you will find these images. Okay, the reason why I put those images there, it's because those are the patterns we are gonna work right now on, or work with. Sorry. So those are images that were generated using Midjourney, right? So one of my first explorations when I got access to Midjourney was this kind of exercising where I used to create patterns, normally using the tiling parameter in Midjourney in order to create this kind of infinite patterns. So this kind of infinite patterns can be easily done using bobs or using noises in general in Houdini. But I just wanted to test this idea in order to iterate using different type of patterns created synthetically. So this was even before stable diffusion was a thing in Houdini. So if you haven't installed MLOPs, it's okay. You can try to experiment creating images with Midjourney. So what I'm going to do is I'm going to share the prompt. Let me look for my prompts. Where they're here. So this is basically the original prompt that I use when I used to use the version 4 in Midjourney. You can also use this updated version that you can use in the latest version of Midjourney, which is 5.3, if I'm not wrong. Feel free to edit it. By the way, change it as much as you want. This prompt is yours now. Keep in mind that I'm using this parameter style raw in order to get a more photographic style in a way. So I just want to be sure. Okay, I made a mistake. I forgot to put an additional line here. Yeah, okay. Sorry, I forgot. I'm gonna copy it again. Okay, that's what you need to copy. I forgot to copy those horizontal lines properly. Right. So those are the type of this is the prompt you can use right now. Or you can play with my own images. It's up to you. It's up to you. Okay. So for this particular exercise, I'm gonna use those, not all of them, maybe a couple of them, because in this particular process, I need to import everything manually. So yeah, back in the days when I used to play with Midjourney and Houdini, it was quite a tedious task to import everything manually. And well, that ended up when stable diffusion appeared. So iterating was a very simple process. So in this case, what we are going to do next, or what we are going to do now, it's we're going to import all those images inside an environment that is called COPS. So inside Houdini, we have this environment in where we can start editing images. Okay, so let's imagine we have like a small, very compact Photoshop inside Houdini. This is what we are gonna use now. I know that tomorrow in the webinar for tomorrow, Kedar is gonna be teaching. He's gonna use as well COPS, but as I remember, you're gonna explore a little bit more MLOPs inside COPS, and it's something really cool. So I'm not gonna go deep into COPS because tomorrow, if you wanna learn a little bit of more COPS, you can sign up for tomorrow's webinar. Cool. So the idea is to create this kind of pavilions or domes, something very simple. The idea is to create patterns, this kind of patterns that can be iterated quickly later once we start using MLOPs. So for now, I'm going to try to create this kind of structures that looks more like this kind of columns, weird columns that I have here. And let's start. I'm going to minimize this. I'm going to go to my file here. And let's start, okay? Keep in mind, if you have any questions, put it in the Q&A chat or put it in the chat, it's okay. I'm fine with it. So now that I have saved this file with another number, this is exercise 2, but I'm gonna keep the previous containers, but they are gonna be off. All of them are off, okay? I'm not gonna use them. So that means I'm gonna create another container, a geometry container. This is going to be the exercise 3. Let's call it object 3. All right, I'm going to go into it. So how can I import images? Or how can I import any kind of object in general in Houdini? Basically, if we want to import objects, so it means OBJs, FBX, ABCs, even DXF, STLs, and so on. Even I think you can even import PDFs. The file, the component you need to use is file, the file node. Okay, this is like the universal component for importing. I'll turn my camera off now. The thing is that I don't want to import geometries as images. JPEGs are not geometries. They are rasterized images, pixels that contains color. So that's why we need to work in another level or in another type of container. This is called COP, the COP2 network. Okay, this is another container, and if you see carefully the icon, you will see that it's more similar than the one we used to have here, IMG. It's because it actually is this particular environment, right? The thing is that what I'm doing is I am trying to go to the COPNet, or it is to the image network from the geometry network. This is quite a bit weird to say it, but it's like we are now in the geometry. We have like different environments, material, we have a stage, we have tops. Each one of them is independent. But the thing is that, for example, we can create a container here, but inside here, I can create another environment that is called material, which is this one. So for example, inside the stage where we render, I can create a geometry container with, an object container. So we create this kind of network of communication in Houdini where we can create environments inside other environments. It's a very complex and unique way of working in Houdini, but I think this is extremely powerful because we can communicate to all the environments independently, or we can create like small communications inside another containers. But I think it's really powerful because if all of those containers can be automated by using the task environment. So basically, this is the one that could control everything. So you can do everything you want in Houdini. You can automate Houdini in so many levels, so many levels. That's why I think Houdini is extremely powerful. So I'm gonna clear my drawings. And as I am creating another environment inside my object environment, I need to double click on it and go into it. Okay. So if I click tab here, you will see that we have other types of components. So there is no geometry components anymore. All the components that you see here are components that will give me the possibility to change or edit images. Oh, by the way, here we have an MLOPs component. Probably you will use this tomorrow. Okay. So as I said, this is more like a small Photoshop inside here. Great. And here we have, here in the managers, you will see that we have more networks. Those are other environments. So I can call up, I can create, I can link other environments inside here. So it's more like creating an inception thing, you know, we create an object inside image, then another image, another geometry, and so on. So we can stay in this loop. So the good thing is that we never lose communication with any environment here in Houdini. Cool. So what I'm going to do here is I'm going to import my images. So as I said, the component that we use to import objects is the file node. It's not different here in the COPNet network. I type file. The thing is that instead of importing objects, I'm going to import images. So this is the default image we have. And what I'm going to do is I'm going to import one of the images that I have. Okay. So in this example, those used to be the amount of images I imported. For obvious reasons, I am not going to import all of them, maybe just 2 or 3, just to demonstrate how this works. So obviously we need to look for the file. Okay. So in this case, I'm going to just paste this path because this is where I put all my pictures. The thing is that for some reason, you will see that I have here 36 images, and for some reason here I just see 1. Okay. If something like this happen, do not worry because Houdini thinks that we want to import an animation. That's why here it says a trace, which is the name of the file, and here this particular expression appears. So basically it's saying that Houdini thinks that I want to import an animation. The reason why this is happening is because I put the names in a sequence. I created this sequence name. No? So the first images was called trace 0, the next one was called trace 1, and so on. That's why Houdini assumes that I want to import an animation. It's not an animation. So what I need to do is I need to click on this show sequence as one entry, and now we will be able to see the images. Okay, I just want to import some of them. Okay, I'm gonna copy it next to it. I'm gonna change it. Okay, this is what I did manually with all the images. Okay, I'm just gonna import like 3 of them for now. Okay, so now that I imported images, all of them are activated, as you may see. Okay, but there is one of them that has this orange button activated. Basically, it's saying that Houdini is rendering or is finally showing this particular image. So I need to click on it to render it, or I can click on it to render it on and the rest. So this is the way to tell Houdini that I want to use a particular image, the workflow, right? The thing is, how can I decide between them how can I iterate a process using any of them? Well, here in Houdini, if I grab all of them and I take the cables and I press tab, we have the well-known switch component. So instead of rendering the first images, I'm gonna turn this on and I'm gonna render the switch node. So for those who comes from Grasshopper, this switch node works similarly than the one we have in Grasshopper. I think this is called string filter in Grasshopper. Here it is called switch. So basically I have my slider here where I can change, I can iterate the image, okay? So the more inputs I have, the better, or the more iterations I'm gonna have. So the thing is, I'm going to go back a little bit, one step. I'm going to change shape. The thing is that I want to have the possibility to iterate this image, not inside the CopNet, but in an upper level here on this parameter. So the thing is, I need to export this slider on this upper level. So the obvious question is that even possible? And the answer is yes. Everything is possible here in Houdini. I'm going to save this file. And I want you to carefully pay attention of what I'm going to do, because this is quite a bit tricky. It's easy, but tricky the first time. When I wanna export a parameter, keep in mind that when we were inside the attribute Bob, in this environment where we were working more like a Grasshopper style, all our parameters used to have an engine at the end here. Now we don't have it. So if we remember, I can go back to, I think it was the first one. Let's go to the attribute Bob. Okay. Even though my script is not working, I have the possibility to see what's happening here. When we used to be here in the attribute Bob, our components used to have this wheel at the end. So we used to click on it and promote parameter. The thing is, and finally we used to have the parameters up here. The thing is that inside here in the CopNet, this slicer don't have this wheel. So in order to export this parameter to an upper level, we need to do a trick. This is what we're going to do. We're going to click on this wheel up here. Okay, this one, the one that is here. Okay, this is quite a bit tricky, but I'm going to try to do it very slowly. Okay, I'll click my drawings. Okay, the first thing is click on the CopNet, click on this wheel, and here we have an option that is called Edit Parameter Interface. I'm going to click on it, and this window will appear. Do not get frustrated with this. This is very simple to read it, but I am not going to close this. I'm going to put it next to me. Okay, I'm going to put it next to me, and I am going to double click on the CopNet. So that means I'm going to go into the CopNet. Okay, without closing this window. Okay, so what I'm going to do is something very easy. I'm going to grab the input index slider and I'm going to release it in the existing parameter tab, like that. Just that. So what I'm doing, I'm kind of creating a new parameter in my CopNet component in the upper level. Those parameters that you see here on the left side are parameters that we can create from scratch. As I don't want to create parameters from scratch, I don't care about them. What I want is to import an existing parameter, which is in this case is the input index. So I am placing it in the existing parameters tab. Nothing else. I don't need to do anything else. Just apply, accept, and you will see that now my input index turned green. That means that this is control from other place. In this case, in the upper scale. So in the upper stage or upper level. So now I have my input index parameter. I can put 1, it will change. I can put 2, it will change. So the more images that I have, the better. So if we see the reference file, we'll see that this CopNet has a switch index that goes from 0 to 35, I think. Yeah, to 35. So all of them are possible iterations that I imported, right? But apart from this, we have another parameter that's called operation. So let me show you what I did here. Inside the CopNet, right now, we have the possibility to go from this RGB image to this black and white. So at the end of the day, when using patterns, it's better to work with black and white images, okay? It's better to control the gradients of the colors using black and white images. It doesn't mean that we cannot use color RGB images. The thing is that it's quite a bit complex, more complex to deal with it. So what I'm going to use here, it's a node that is called mono, which is Oh, it stands for monochromatic. In order it to work, I need to activate it and render it. Okay, so from here we have operation. So if I go to the first images, now here I have the possibility to use a different type of algorithm that will convert the color into a different type of black and white gradient. So basically this is the exact same component we use in Photoshop to convert an RGB image to black and white. So we start using operations. Okay, so basically magnitude is the one that keeps the contrast the best. So what I'm going to do is I'm going to repeat this process. I'm going to export this operation tab by going back, selecting the CopNet, going to edit parameter interface, then without closing this window, enter into the CopNet and just grabbing and releasing down here the parameter. Apply and accept, go back, and that's everything we need to do. Now we have the input index and we have different operations, algorithms. That's cool. That's everything we need to do. Cool. So the thing is that right now we have this image that is based on RGB pixels, okay, or RGB polygons, sorry. Well, each one of them are pixels. The thing is that in order to create an object, I need them to be converted to at least lines, okay? As RGB image or this kind of pixelated image is not so helpful for me, at least for what I'm planning to do now. So that is a good way to convert an image, a rasterized image, into a vectorial drawing or curves. So this is something that we usually do in Illustrator. There's something very common we do in Illustrator. We usually import our rasterized images and convert them into vectors. And that's something we can do as well in Houdini. So the node that I'm going to use, it's called trace. This is the one, okay? The tricky thing is that I am not going to connect it one after the other, okay? This is not how trace work. So if you try to connect, nothing is going to happen. You need to keep this clean. Okay? This is pretty weird, but this is how the trace node works. The thing is that on trace parameters, we have trace, we have filters. We're going to use this later. But on the trace tab, we have other tabs. One that is called file and other that is called comp. So what I can do is I can import an image directly from the computer in order to convert this into a vector, or I can link the trace using the comp tab. What's the comp? Well, this is the CopNet. So basically what I'm saying here is I want to import whatever I did on a very particular COP network. Keep in mind, this particular COP tab works not only for the one that I have here, but for any kind of COP container that I could have in all Houdini. That's why this is asking me for a path. So this path could be the path of this particular COPNet or any other I could have in any other container. Okay, keep that in mind. I'm going to clear my drawings. I'm going to go back here. So what I need to do is I need to define the path. So this particular container have a path. I don't know the path, but I know it has a path. So everything here has a path. Basically, the path is the one that is up here. So if I click on it, basically this is the path. So the question is, how can I type this path? Okay, so this is very easy to do. But actually Houdini does the job, not me. So I'm going to go back. So I'm going to click on the trace CopNet. And here in the code path, I'm going to click on this open floating operator chooser says. Click on it, and you will see this window. Basically, this window is showing me more or less looks like an outliner. So basically, it's showing me the path. So basically, I need to look for the location of this CopNet. So I know this CopNet is inside the object environment, inside the object 3, inside the CopNet is the element I want to use. And the question is, which one of those components I want to use, but basically the last one, the mono. So probably, okay, there is nothing here. So that means I need to use the last component I created, which was the mono component. I'm going to put accept, and that's enough. So basically what I did is I defined the path of the last component that is inside here, this CopNet. And voila, that's basically everything we need to do. Nothing else. So by default, it's converting the rasterized image into a vectorial image, as you may see here. So I have points, I have normals, so it's now a geometry here. The thing is that I can change some values here. If I go to filter, I, for example, can delete some elements from the border to clean this up. So if I click to remove borders, I can delete, I can delete those kind of surfaces that I have that I don't want to use. So the higher the value, the more I reduce the borders, you can say it that way. So let's keep this into 5 or 10, it's okay. Then we have resample shapes. What resample shape does, it's like it reorganizes the point distribution on the lines. This resample node, it's like the rebuild component right now. So I'm gonna keep this into 10 maybe. That's okay. That's okay. And then I can smooth the shape to make it smoother, but it's not working very well. But anyway, let's keep this like that. Cool. This is how I vectorize my own images in Houdini. Super. But the next stage is I have another possibility. I can create lines or surfaces like that, or I can even use another component that is called curve. This is really cool. This is a really cool component here. Because from here, I can also edit my curves. So I can change like, how is this called? This order parameter is what we know in Rhino as degree. So basically I'm like editing the curve degree. We have until 11, I think. So I'm gonna keep this. So the higher the degree, like the more complex the image, the Bezier is gonna be. Right? The more control points our Bezier is gonna have. So let's keep it into 4 or 5, I think. So cool. So now my curves probably are cleaner. So yeah, let's keep it into 4, not more. So by default, Rhino works with 3rd degree. All the Bezier curves are 3rd degree. NURBS curves are the 3rd degree. So but now I need to get rid of those surfaces here that I don't want them to have. So basically we have 2 ways to do it, by using extract borders, or the other one is to use ends. So I remember we use like extract borders. I think this is one cool option. And the other one is ends. So in this case, I need to define that I want to open, preserve the U. Simple as that. So if we consider we still have too much points, we can do another resampling by using the resample node. I need to increase the amount of points, obviously. So in order to increase the amount of points, I need to reduce the length, maybe somewhere there, no, 0.01, I guess. Yeah, more or less like that. And then I can even smooth the curve by using the smooth component. Okay, it's okay to smooth the position in order to make it smoother, like, I don't know, maybe 15. Right. So this is how I came from this image, this rasterized image, to these vectorial curves. Simple as that. Cool. Just to be sure now, I'm going to fuse them. Okay, with a fuse node, we just be sure that if there are some points that were open, now they're, or the curve, if there were a curve that was like exploded, now everything is joined. So the higher this snap distance, the more join is gonna be. I don't know how to call this, but anyway, I think we can keep this into 0.1 just for those, just to keep our tolerance in order. So one of the things now that happen is that, and on this process of doing this kind of vectorial thing, there is something that we lost. And basically, let me see. Yes, something that we lost is normals. All our geometries usually have normals. In this case, the curves doesn't don't have them, but the surfaces do. So during this process, we lost all our normals, and normals in this case are extremely important, as what we want here, what we want to do later on a later stage is to extrude the mesh, right? So we need to create the normals somewhere in this process. Okay, so there is no way to create to control a normal so easily. There are some components that can give me the possibility to create normals, but I want all of the normals be the same. So in order to create normals, first of all, let's do a very short explanation here. If I want to extrude this curve, right, I can use the point normal. But if I do something like that, I'm going to turn this off. Something like this will happen. Some elements will go to one direction and other to the opposite direction. So let's mind this is, in this case, this is positive Z and this is negative Z. So by default, Houdini is creating some normals, but the normals are doing whatever they want. Okay. And this is something that shouldn't happen. So I need to have control over the normals here. So I want the normals to point either positive Z or in this case negative Z. Whatever of those is gonna be great. But the point here is that all my geometries, all my curves needs to have the same normal. So what I'm gonna do is I'm gonna create normals manually. So the way to do it is by typing. We are gonna create an attribute. So my component is gonna be called attribute something. So if I want to create a code, I need to use the attribute wrangle. Okay, the attribute wrangle, you will see that has this window here. So basically, this is the monitor where we do coding in Houdini. So the piece of code that I'm gonna copy paste it basically here. So this is the actual code we're gonna use right now. I'm gonna paste this on the chat. So for you to just copy paste it. You can copy paste this particular piece of code. The thing is that we need to change some elements here. So by default, if I go to the previous fuse component, we will see that the only attribute we have is P for position. But once let's call this normal. Okay. Normal. But once we go to the next one, now we have an additional attribute that is doing this kind of thing, those yellow lines. Okay, so this is not the normal that we want. But the thing that I'm doing here is I'm creating a normal from scratch. So basically here it says I'm creating a normal, which is a vector, and this is the value of this vector. So we use set in order to create something as a normal is a 3-value vector. It's a vector, so it's a value of 3 elements. I put the X, Y, and Z value. In this case, it's facing up, so it's doing something like that, because it's saying X, Y, Z. Keep in mind that in Houdini, the Z is the 3-dimensional vector, so it's facing up. If I want it to face there, this is Z positive or positive Z. So I need to change it. This is not going to be 0. Z is going to be 1. Like that. So now if I click on the normal, come on, one. Now if I click on the normal will be pointing the same direction to Z, like that. Cool. So I'm going to turn this off. And now if I turn the poly extrude on again, you will see that nothing changed. It's because we need to define that now I want to work with the existing normal. So in the point normal, instead of pre-computing, existing, and just that. So from this point, all my element will be extruded just in one direction. Like that. Great. So for now, I am not gonna use the poly extrude yet. I just need the normals for now. So the next thing here, what I want to do here, I want to separate whatever all the curves that are open and I want to separate the open curves with closed ones. So I need to make two groups. There is no such a thing of open curves components, so we need to create it from scratch again. So what I'm going to do here, first I'm going to fuse the curves. Yes, I know that I fused previously, but as I am planning to create like a component from scratch, the first thing that need to be sure is that all the curves are joined properly. So what I'm going to do here now, I'm going to create another attribute triangle because I'm going to create a component from scratch, if I could say that way. So this is going to be called evaluate Nate boards, okay, something like that. So this is the piece of code that you will need to let me enter and delete, enter and delete. Okay, this is the piece of code that you need to copy. Okay. What I'm doing here, I'm evaluating if, for example, let's find for a closed curve. How Houdini knows this is a closed curve? Basically by evaluating all the points and checking if each point has two neighbors. So if one point has two neighbors and this logic is the same in all the points, that means this is a closed curve. Because in a closed curve, all the points has two neighbors. This particular logic doesn't happen in an open curve. This is an open curve. In an open curve, we have some points that has two neighbors, but there is always one point that has only one neighbor. That's why this is an open curve. So basically what I'm saying here is, let's check the amount of neighbors. This is a component, neighbor count is a component in Vex. So basically it's saying if we have less than two, if you find that there are points that have less than two neighbors, put it in a list one, and the rest put it in the list number two. Okay, this is what this is doing. In this case, as Houdini doesn't have such a thing as lists as we have in Grasshopper, what I'm doing is I'm creating an attribute that is called isOpen. Okay, so or a group that is called isOpen. So each time Houdini finds a point that has a curve that has points that have less than two neighbors, it's going to create a group and will place that element in a group that is called isOpen. Okay, that's what's happening on that particular script. So that means that if I click on information, you will see now that apart from the attributes, I have a group. So this group has a group that is called isOpen, and we have 88 elements. So that means that what I can do here now is I can delete. Let's just delete. I can delete whatever was happening in the isOpen group. So basically, let's turn this off. Those are closed curves. And if I want to select the open curves, I just change delete selected from delete not selected. So those are open, those are closed. So basically what I can do here is I can grab another delete node. So this is open, this is closed. Simple as that. So, but what I want to do is I want to convert this into a component, a whole component. So what I need to do is I'm going to grab all of them and I'm going to click on this button that is called create subnet. This is more like a cluster creation. Click on it. And now we have the subnet. This is called open close. Let's call it like that. The thing is that I want two outputs, not one. Let's go inside here. And now the environment changed a little bit. You will see that we have, after the first delete node, we have an output node. That means that I can copy this one and I can link this second output to another output. The output component, the only thing is that we need to change is if this first output was set in the index 0, the next one needs to be set in number 1. So if I go back, now I have two outputs, one from the close and the other one for the open. That's how you create a simple component in Houdini. Right. So next, I'm gonna work with the close curves. This is the one that we want. So maybe if I change the copnet to another one, oh, this is nice. Maybe the first one. Okay, this is pretty cool. Let's use this one. This is super cool. So if you want to see what's happening in the other output, what I suggest you is to use a null node. Null node is more like an empty component. It's very useful just to see what's happening in each output. This is closed. This is open. Well, open is not that good. So let's keep into the close and open. Cool. Let's work this way. So what I can do here, for example, I can use a symmetry node to make it, symmetrical. In this case, I want this area to be copied there. So this is basically my axis. So this is the direction of the axis. So this is pointing, let me check. Come on, I want this. Okay, this is pointing minus x, as I see. But this is minus x. Okay, so that means that my direction is -1, 0, 0. This is the vector that I need to select. So I click on the symmetrize, -1, 0, 0. Yeah. So this is the symmetry. Cool. Cool. Great. So what I'm going to do is I'm going to transform it. Let's use a transform node. I'm going to make it horizontal. If I want to rotate it, if I don't know which of those values I need to change in order to rotate something, what I'm going to do here is I'm going to press enter on the viewport. You will see this kind of gizmo appearing. If I rotate it that way, now I see that the value that I'm changing is x, so I'm going to put 90, and that's okay. Just in case to be sure, just in case I want to be sure about placing this object in the origin, because I need it to be in the origin, there is one node that is called match size. This is a really helpful component that will give me the possibility to place my object in the origin. If you see, it seemed like it was in the origin, but it wasn't. This is the origin. Okay, just to keep my object organized. Okay, so let's see if I have normals. Yes, I have the normals there. It's okay. So that means that now I can use my poly extrusion node like that. Great. But in this case, I want this to go in the opposite direction. It's when I use positive distance, is going to the negative side of my Z plane. So that means that I need to go back to this normal, and instead of using 1, -1, like that. The issue here is that I'm seeing the back side of each geometry. So the way to solve this is by using the reverse. No, not this one. The reverse node. Is it working? Oh yeah. But now I see a kind of glitch. That means that the normals need to be fixed. The fastest way to fix a normal is by using the normal node. Like that. Now it's fixed. Great. If you want, we can use our friend Quick Material. Keep in mind, we need to change it to MatCap. I have one in the desktop. Let's use this pinky one. It was really beautiful. Cool. And now let's try to change something. As you may see here, this is very straightforward. This is very easy. I just created vectors. I separated the open from the closed curves, so they're separated now. I'm just extruding it. Simple as that. It's not that hard. The thing that what I'm going to do here is let's try to edit it in a way it look more like this image. Okay. If you see carefully what's happening here is that this kind of pattern used to be a simple extrusion. So what I did here is I make some taper here and some extrusion here, and that's all. This is manual work. So this is something that I didn't see so much people doing in Houdini, which is manual work here, but it's something that I'm going to do. So first thing, what I can do here is first let's use another deformer. Let's use the twist now. Okay, let's do the twist now. So if I want to use the twist node, I need to press the best way to use a deformer here in Houdini is by clicking on the viewport and pressing enter. We will see again those letters here. So we're going to see this bounding box. The first thing we need to do here is to define a proper bounding box by pressing fit capture. Great. So if I rotate this wheel, you will see something start happening, but this is not the way I want to rotate it. I want to rotate it using a vertical axis. So I need to cycle capture. B. Okay, that's fine. That's fine. So now I can rotate my geometry. Maybe just 45 degrees, something like that. I think it's okay. But as you may see here, it's being rotated in a very weird way. We don't have any kind of interpolation here. It's just because we don't have subdivisions on this axis. That's something easy to solve. Let's close this thing. We need to go back to the extrusion. And in the extrusion, the only thing we need to change is subdivision. So what I'm going to do here, let me Control Z, I'm going to add more subdivisions. So if you see carefully here, we're adding more subdivisions. In the extrusion, let's put it 30, like that. So now once I go back to twist, okay, something different is going to happen. 45. Yes. So now it's different. So I can see an interpolation there, a smoother interpolation, which is cool. So great. Next step is to add some thickness by using the thicken. Ooh. I think it's too much. Let's put 0.01. Even less, I think. 0.8. Oh, that's better. So my geometry has some thickness. Then let's try to clean the normals. Each time we do extrusions or we twist our geometry, our normals usually gets ruined. In this case, I think I'm gonna reduce the size of my normals by default. I'm gonna change the size of these normals. I think they're too big. So the way how I do it is I press D from display on the viewport, then I go to guides, and we have scale normals. So from here, I'm going to reduce this value maybe to 0.10, maybe less 0.08. Yeah, that's better. Save as default. Okay. So I think normals are not that bad, but I prefer to clean them up using the normal node, just in case there is one normal that is not properly placed. Then next step, what I did here is I separated again the biggest objects from the smallest by using delete small parts. This one. Okay. But in this case, I will play with the threshold. So the higher the number, the more elements I will delete. Maybe something like that. No, let's put 1 maybe. Yeah, let's keep it like that. And then what I'm going to do is I'm going to use taper. What I'm going to do is something very simple. I'm going to press enter, fit capture. I'm going to rotate this axis vertically by using cycle capture. Yes. And what I'm going to do here is I'm going to make the upper part like really small, like that. And maybe the interpolation also would be something like, oh, let's change it to smooth. Yes. Maybe like that. And this is going to be smaller. Great. Now it looks better. Maybe a little bit more. Great. That's cool. That's super cool. So next, basically what I just modeled here, and let me rotate this object. I'm gonna rotate it 180 degrees, more or less like that. Cool. But now the top part is below the C-plane. What I want now is my object, this bottom part, to be on the origin. So I need to move it vertically. I can use the transform node to move it, but the thing is that if I change the size, I will need to go back to the transform node and move it manually again, and that's something that I'm not planning to do. So again, we can use this match size node, okay, in order to place the object in the origin. But by default, it uses like the centroid of the object to place it in the origin. What I want is the bottom part of this object to be placed on the origin. So as this is a justify component, we have a justify y. Instead of center, let's put minimal. Okay, that's how we like place properly our object in the origin. I really suggest you to always try to work with your object in the origin, because basically transformations and deformations works the best when you have your object in the origin. So now what I want to do here is let me see if I can do it. Okay, what I'm going to do here is I'm going to grab all the points from the borders here and I'm going to extrude them, right? Well, not the points, but maybe the primitives. I'm going to extrude them. Let me see if they are working there. Well, hopefully they are there. I need to be sure that this is close. Okay, they're close. It's okay. So what I'm going to do now is I'm going to make a group because I want to grab all those bottom faces in order to extrude them. So we have the possibility to group manually by selecting face by face. Okay. For obvious reasons, I am not going to do that. So instead of grouping manually, I'm going to group by bounding regions. So in the previous exercise, we used the bounding object as a way to group something. But in this case, I'm going to use a bounding box. So if I press enter here, well, sorry, where is my box? Okay, we have a box here. I can make this box smaller. And this is the one who's gonna group everything. I wanna group maybe somewhere, something there, maybe a little bit more. Okay, hopefully this will be enough. Hopefully. So cool. So next, I can use the poly extrusion now. But what I'm gonna extrude is not everything. It's not everything, but just whatever was grouped in the previous component. So let's call this base. I'm gonna go back here. I'm gonna change this to base. And from this point onwards, I can go to point normal. But the thing is that if I try to extrude, something like this is gonna happen. Okay, it's because we need to set the normals properly. So what I can do here is I can copy paste the normal component. Let's paste it here. I'm gonna save my file, right? So we have the normal, but in this case, I want the normal to point minus y. So in this case, -1 here, 0. Click outside. And now I need to define here that I want to extrude it through the existing normal. And this is more or less what I have. Great. Something like that. I don't want the output front, just extrusion. Simple as that. Maybe I can add some subdivisions. 7, it's okay. And I think it's fine. Great. So, well, actually, let's put a null now, because honestly, we don't need to do anything else. So basically, let's use a match size now, just to clean the file, and to organize the file, to put it somewhere like that. Maybe there is one more thing we need to do, which is cleaning the normals. Finally, using the normal node. Yes. And that's basically all. Okay. In the reference file, you will see that this process is quite a bit more complex, which is basically deforming the mesh a little bit more. But the good thing is that we created now the workflow that can be iterated just by going back to the CopNet and just changing the input. So as you may see here, the more inputs you have, the more possibility to create this kind of objects, which is basically a very simple extrusion. Okay, simple as that. Simple as that. This is basically what I did to create this kind of elements. So, what about the next one? Okay. We're almost finishing. We have time. We have time. So, this is basically how you create objects using Midjourney. Keep in mind, the more patterns you can import here, well, the better. The sad side, I mean, the bad part, or the bad side of this process is that this workflow is manually. So you need to import objects manually. And that's something, I mean, we don't have the time to invest to do that. So what I'm going to do here now is I'm going to close this. And let's go back. I'm going to turn this off. I'm going to save my file. And now we're going to create a new container. Give me a second because I have my reference here. Great. So this is going to be, let's call MLOPs. Wow. Okay, so now we can work with MLOPs. Let's go inside here. So MLOPs works in a very particular way. Let's go to our, okay. The thing is that what you're seeing here, it's also patterning creation. So basically I create the patterns, I transform them, I extrude them, and etc., etc. I mean, the process, the main difference between this particular exercise and the previous one is that basically in the first one I used Midjourney, and the second one I'm using a Stable Diffusion. That's the main difference. But the good side of, the best side of this workflow is that we will have the possibility to iterate patterns inside Houdini. So there won't be this idea of manual working, creating images in Midjourney. We can do it natively using Stable Diffusion here in Houdini. So the way to use, let me close my previous file because I don't want my computer to crash. Okay, because now Stable Diffusion is going to be quite a bit hard to use in a way that it's computationally heavy. So each time, keep in mind that from this point onwards, each time we wanna iterate using Stable Diffusion, you will see that we will need to wait some seconds, even a couple of minutes, to create new iterations. Keep that in mind. Okay, keep in mind I'm doing a live stream, which is using my GPU, and I'm gonna use a Stable Diffusion that will also use GPU. And keep in mind we are using Houdini that also use GPU. So in order this to work properly, you need to have a really powerful computer. Keep that in mind. So just to remind you, if you go to, I am not going to explain MLOPs in detail, as if you go to the SideFX webpage, not specimens, but let's try to look for it very quickly. And if you go to learn and tutorials, I guess, let's try to search MLOPs here. Hopefully there is. Yes. Okay, let's not play. Okay, I'm gonna share this link in the chat. Okay, because the developer of MLOPs, which is Entacma, and this other guy, whose name I forgot. Okay, Paul. Okay, Paul and Moritz. Moritz is from Entacma. I really suggest you to watch his tutorials. He's the real guru of Houdini. They both developed MLOPs for Houdini, and they have a very detailed group of tutorials in SideFX webpage. So if you want to know even how to install MLOPs in your computer, you can watch their videos. Even they have an update on the second version of MLOPs. So as there is this set of tutorial, I'm not going to explain that in detail because you have it here. So what I'm going to do is I'm going to try to show what I did in order to create this kind of structures. Okay, basically this is a regular 2D pattern that it was expanded to a point in where we had this kind of dome structure, okay? So keeping that in mind, I'm going to press tab, and if you install proper MLOPs properly, you will see this MLOPs tab here. We have analysis, hopefully, okay, we have analysis. So we have some components to analyze images. We have segmentation, so we can, like, for example, delete backgrounds or segment it using a control net. We have the stable diffusion components properly. We have, like, we can, like, interrogate images in order to extract prompts. We have utilities in general. So for example, if you want to render images, we can use camera to points. If you want to, for example, export our images, the images that we already created, we can use those components. If we want to upscale our image, we can do it as well. So now we have an upscaler inside MLOps. So basically that's everything we need to know about MLOps. But the first thing we need to do is we need to create the prompt itself, right? So keep this in mind. First, we're gonna create, like, the longest procedure from MLOps, and then we are gonna work with the shortest procedure, okay? Keep that in mind. So the first thing we need to do is we need to create the prompt. So we have this MLOps prompt create. Put it like that. So the thing is, we need to differentiate whatever is positive from negative, right? So in this case, I'm gonna copy 3 of them because I wanna do something very cool later. So this first one, it's gonna be called, I'm gonna change the name, okay? So this is gonna be called positive prompt. And this next one is gonna be called negative prompt. Cool. So I'm gonna paint this green, I'm gonna paint this red. Cool. The thing here is that we have the possibility to type the prompt we want there. Okay, so I'm gonna copy my prompts here because I already have my prompts. Oh no, sorry, this is positive. I'm gonna create a pattern. So basically, okay. So I'm gonna copy those prompts as well in the chat. So the positive, so I'm gonna make it positive. I'm pasting on the chat. This is my positive prompt. And the next one, it's going to be like the negative prompt. Okay. Basically, this is what I copy. You may be asking why I add those parentheses here. It's basically, this is how you add weights to your prompt. So I saw some people using up to three parentheses to add more weight. Other people use, if I'm not mistaken, something like that. They add a value at the end, but I usually use parentheses, right? In this case, I prefer to separate my lines because for me the positive prompt needs to be more clear than the negative. So in the negative, I just place some simple words, but as positive prompt contains ideas, I prefer to separate them in lines. Okay. The thing here is that prompt, it's itself a string. So if I go to the geometry spreadsheet, I need to go to, let me check where is, okay, so it's on the points. So if I click here, you will see that we have a prompt attribute here that is basically the text. The thing is that we need to convert this text into a token. So basically, each time we use AI tools, basically what we are creating our tokens. So that's why here we have a tokenizer. So hopefully this will run. Yeah, okay, oof, great. Hopefully this runs. So basically what he's doing is creating a token. This is the most important value here, the token. So I'm gonna create another token for the negative prompt, right? And then we need to combine positive and negative. So this is by using the encoder. And here it is, the text encoder, right? So here we're gonna put positive tokens, and here negative tokens. So basically positive prompt, the first one. Let's wait a little bit. This is why it takes time to compute. Hopefully my Houdini won't crash. Yay. Nice. So I'm gonna copy this to the negative. So this is basically how a prompt is created properly. Okay. This is how you create prompts in Houdini. The reason why I have another positive prompt here, I'm going to show you something that is not that common here in Stable Diffusion. So I'm going to copy another prompt, which is going to be this one, right? I'm going to copy that in the chat. And obviously I'm going to copy tokenizer. So basically, as you may see, I have two positive prompts. So that means I'm going to use another encoder. Cool. So basically, I have now the possibility to change prompts on the go. So basically, this is my first prompt, and this is my second prompt. Okay, so if I use a switch now, I can change prompts very quickly. But the thing is that I want to use here, it's something that is called blending. So what I can do here, and that's something really cool, is that I can grab this, let's say we can apply like a weight for the whole prompt, and I can do a blending with another one. So for example, I can say, I want both of you to be, you together should be 1, because this is like giving 0.5 and 0.5 of its weight. But I can say, no, I want this to be more important than the other prompt. So I can create like a blending. This is something really cool because this is something you cannot do in other software, just in Houdini. You can like create a blending between prompts. So you can do this with a very small piece of code that I'm going to copy the chat, basically. I'm going to use an attribute triangle here. Let's call this blend. Okay. So basically what I'm going to do here is I want to connect this way. And I'm going to copy, I'm going to copy the code, okay? So this is the piece of code I'm going to copy, but basically this is separating the unconditional with the conditional, because each time we create a token, we create conditionals and unconditional. So basically we are combining both of them and using this channel float blending parameter. So basically I'm creating here a parameter that is called blend. The only thing you need to do is once you copy it, you need to click on this icon up here that says creates spare parameters. If you click on it, you will see that we have a blend parameter. I'm going to put it in the middle, right? So so each prompt, it's giving like 50% of the value of the final value. So this is the code. So I'm going to share it to the chat like that. Great. This is a cool thing here in Houdini. We can blend prompts. So later we can play with this blending parameter just to define maybe the first prompt is more important than the other one, right? So I'm going to save the file now because this is where the heaviest part starts. So once we define our proper prompts, we need to use something that is called the scheduler. Scheduler, this one, MLOPs scheduler. Okay. This is the one that is running the algorithms. This is the one that is running the iteration or the quality iterations, the guidance, and even the libraries here. So what we need to do here is we need to link text in the first one. And in this second input, we have something that is called noise latent. So basically the noise latent is this component that gives the information about resolution and the seat. Okay. So what I'm going to do is I'm going to define the height that is going to be 600. From this point onwards, what I want is each time I create an image, I want it to be square. So if I change this first value, I want this first value to change the second one. the way to do it, the way to link the first, let's say one parameter to other one is by right-clicking on the first, put it copy parameter, right-click on the second, put paste relative references, enter. So each time I change the first value, the second one is going to change automatically. So I'm going to go like 600. And here I can put the number I want. This is just it. Okay. I'm going to connect this to the second input. Now, once I turn this on, I need to wait. I need to wait. Because right now what's happening, it's Stable Diffusion will start running. Cool. Okay, now okay, I don't see any kind of error, so that means that something is happening. Let me see. I have unconditioned. Okay, I have the latents, which okay, guide latent. Okay, it seems it's working. So now that everything was properly assembled, now I need to run the solver. So basically the solver is the one who does the final job. Okay, so I'm going to connect it here, turn this on, and this is the one that is going to do magic. So let's wait a little bit. This probably will take maybe a minute because we need to wait Stable Diffusion to run. This is the heaviest part of using MLOPs here. Okay, it's running. Nice. Cool. So I'm going to press F on the viewport. Okay, F stands for focus. So what I'm seeing here are just points, just regular points. The thing is, let's see my attributes. So basically what I have here is a whole set of points that is doing nothing, but they contain information. So I need to translate those point information into something we can see. So basically that it's called decoding. So let's use image decoding. This one, okay? If I connect this into this, let's wait. And now we will be able to see something. Okay. The thing is, until this point, everything are points. All are points. Probably points won't help me too much later, but the thing is now we have the points. The thing here is now we have the possibility, for example, to go to the latent noise and change values in order to iterate the image. We need to wait a little bit, but now that Stable Diffusion is running, each iteration is going to run faster, right? So for example, here, the thing with my blending is that I can change, for example, how important my prompt is. So maybe if I want the first prompt to be more important, I will put 0. So this will make just the first prompt to run. Okay, this is the first prompt. And then if I put 1, just the second prompt will run. So this is the second prompt. If I want a blending, 0.5 is okay. So you can play with it as much as you want. Okay, so maybe let's try to find another seed. So as any kind of AI, a generative AI tool, the more time I spend like looking for iterations, the better. Okay, for now I'm gonna keep just in with this iteration. It doesn't look that bad. So the thing is that what's going to happen now is I'm going to more or less repeat the process of what I did in the previous exercise, which is basically vectorizing the image or extruding the image and so on. The thing is that those are points, and those points won't help me, honestly. I don't need them to be points. I need them to be, in this case, first rasterized images. So the way to convert points into pixels, let's call it that way, it's by using the component that is called export image, MLOPs export image. Okay, so from here, what I suggest you here, it's to define the proper output, right? So basically, I'm going to copy this extension, and this part could be quite tricky, but bear with me. I'm going to copy this extension. This is basically an expression to save the file. Basically, $OS stands for, this is an expression that means that the file will have the name of this file. So if my file is called x02, that means that my output images will be called x02, and the name of the frame, which is no, 1, something like that. Okay. But I don't want that to happen because each time we run an export image component, this image will be saved on the computer. So let's do something. I'm gonna copy this and I'm gonna select my file, my folder in the computer. I'm gonna create a folder that is called out. Okay, out01. Great. So here I'm gonna save my file. I'm gonna put this name, accept. So I just create the path, right? I just keep the original name, but I'm gonna do something. What I wanna do is I want to save this image each time in a different way. What I mean is I want this file to be saved depending on its seed number. So if right now I save this file, I let Houdini to save this file, I want this file to be saved with this number. So next time I run Stable Diffusion in my computer from scratch, I don't lose the seed number. So I can on a later stage, I can go back to this particular iteration just by typing the seed. So this is something that I'm going to do. I'm going to right click on the seed, copy parameter, go back to the export image, and here at the beginning, right click and paste relative reference. And you will see this expression to appear. Keep it like that. So with this, I'm saying that this expression is saying that my file name will have the seed number as a name, then the name of the file and the number of the frame. Just let's close it. And I'm going to connect it to the export image. And I'm going to click on auto cook. Click on it, export. Great. So now my image is pixel. It's a pixel image, which is fine. And if I go back to my computer, now I have my image here in the computer. Now it says 2556, which is the name of the seed. So if I go back to my computer and I change the seed to this one, Stable Diffusion will run again. I'll have a new image and I will have a new image on the computer with the seed number. Okay. This is, I think, the proper way to save your iterations independently. So you will never, ever lose your information, right? If you don't change the name of this export path thing, all your images will be overwritten each time you run an iteration. Keep that in mind. Okay, but I want to use the previous one, just 6. Great. Great. So let's continue. Then I'm going to go to match size. Okay, match size, which is this one. It's in the origin. It's okay. So give me a second here. I just want to check my notes because this is true. Give me a second. I need to run another Stable Diffusion iteration just to see my notes. Because as you may see here, there are a lot of expressions going on. So I just need to be sure that everything is working properly. Great. Just give me a second. Okay. The thing is now that now I'm running 2 Stable Diffusions at the same time, so I need to be really careful. Yeah, you can run as much Stable Diffusions procedures if you want here. The thing is, the more you run, the heavier it's going to be. The heavier task is going to be. So now, what I need to do now, is I need to as I'm going to convert this into a dome, because now I'm going to deform it. This is everything we need to know about envelopes, at least for the beginning. Now I'm going to deform this in a way this square can be converted into a dome. So again, this can be easily done by using a group now. So this is going to be called sphere. This is the name of the group. So now I'm going to group points, not primitives in this case. But I'm going to group them based on a sphere. I'm gonna create a sphere here. So that means that in the group, I need to go to the bounding regions object. And now I need to make this sphere big enough to see it. I think I use this size. Yeah. So I use the 650 in scale. And if we want to have more resolution on the borders, that means we need to increase the rows and the columns. Yes, now we have more resolution on the border. Great. So now that I grouped this center part, that is the one that's gonna be extruded, or not extruded, but projected on a dome. I want to separate this group selection with the rest of the areas that were not selected. This is easily done by using the blast node. Here in the blast node, I need to define. Here I need to select the group name, which is a sphere. So basically, it's deleting the internal part. I want to do the opposite. So I click on delete not selected, which is this one. Great. So basically, I have more or less this circular pattern, which is what I want. So let's see if we have a color here. Yes, we have colors. So that means that, for example, I can use a color in order to control the contrast of the image. So let's see if I go to the color and I go to color type and put ramp from attribute, I can type CD, that stands from the color, and probably I should be able to increase, yes, I should be able to increase the contrast. So if you can see it, by moving this color ramp, I can tweak the contrast of the image. Right, which I think is great. I'm not vectorizing the image, I think the use of this ramp, it's a good method to control the contrast of an image. So next, I'm gonna create another sphere. So this next sphere, it's gonna be like my target. So this sphere will represent, let's make it quite a bit bigger. Yes, so it's maybe quite a bit smaller than the other one. Yes, it's okay. So this is going to be called dome. So this is going to be my target. So I need to create the target. What I'm going to do is, now that I have two objects, what I want to do is I want to grab this planar image, and what I'm going to do is I'm going to project it to the dome. Okay, so I have like the reference image and I have the target image, or the target object. So the first thing is I need to model the dome. This is a sphere. I need it to be a dome. So what I'm going to do here, let's create the drawing. Is it okay? Yeah, is it okay? So what I'm going to do here now, it's now that I have the dome here, I need to delete some parts of this particular sphere. So I'm going to delete it just along this direction, so in the middle. The thing is that as this is a mesh, we don't have control over the UMB, the UMB vectors of this object. So what I'm going to do here is, instead of working with polygon mesh, I'm going to change it to NURBS. Yes. So now that I have NURBS, we have control over the U and B. Because the next step is to use the carve node. Okay. The carve node works best if we have UV attributes on our object. So basically, I'm going to turn this off and turn this the second on. Let's see if this is the one that we need. Oh, yes, this is the one that we need. So I'm going to go 0.5. So basically, that's the dome. And then I convert it back to a mesh, because I want my object to be projected on a mesh, not a NURBS. So as you may see here, you can also work with NURBS in Houdini. So let's see if by adding more subdivision it's better. Yeah, the more subdivisions we have, like the more resolution our projection will have as well. So in order this projection to work, because there is no way to project an object properly, I mean, we have a component that is called ray in Houdini, but this particular component doesn't do the magic, doesn't do the trick that I want Houdini to do. I want this image to be projected based on its closest point. This ray, what ray does is only push the image along one vector. In this case, I want to have several vectors. So in this case, the ray component won't help me at all. So let's do not use it now. So in order this to work, I need to have 3 elements. Okay, we need to have like the planar image. Then I need to have like the dome, which is the target. And I need to have like a reference. So this reference, it's basically the dome, like, but scaled in 0, like that. This is what we need to have. Like, so we have like the image, we have like the reference, and we have like a target. So now what I'm going to do is I'm going to use an attribute wrangle. So I hope this works. So let's call this SYZ distance. Okay, what this component is gonna do, it's basically it's gonna find like the closest point. It's like using closest point in Grasshopper. So I'm gonna connect them this way. So I'm gonna copy again the script again here. So hopefully this will work. This should work. So this is gonna project the image, the planar image into the dome. So hopefully, let's wait. Let's see. Hopefully my computer won't crash. Did it work? It didn't work. Okay, so let's see what's happening here. Maybe I made a mistake. I think everything's okay here. Let's see, everything is working fine here. I have my plasma here. Maybe I don't need the color. Oh. So I have the dome. Okay, maybe the problem is here. Let's try to go like 1 here. Maybe I don't need them too much. Let's see why this is happening. Oh, okay, maybe, okay, I made a mistake here. I don't need to, I need to create a 2D projection, but not from the dome, but from this element as well. Yes, not the dome. Because we are not deforming the dome, we are deforming, we're not deforming the sphere, we are deforming the dome. Okay, so from here, it's okay there. So it's okay to have this resolution. I'm going to save my file. So I think we can use the color and this should work. Yes. Okay, so the error was here. I was trying to project this planar image on the dome. So obviously for obvious reason that is not supposed to work. I'm just projecting now my element on this particular sphere. The reason why I made this kind of linear cut, it's because I want to have the possibility to have openings, basically because of that. Great, so let's continue. I'm gonna fuse them. I'm gonna work quite a bit faster because we're almost reaching to the end, and I think we have, I think, two more exercises to show. So let's see the borders. If the borders are fine, I think the borders are fine. So what I'm going to do next is I have basically 2 colors here, right? So what I'm going to do is I'm going to try to separate whatever is black from white. So basically, I'm going to have 2 different groups here. So what I'm going to do is I'm going to use a component that is called cluster points. Okay, let's turn this on. This will take quite a bit to compute. So what this is doing by default, it's kind of creating a group based on the position of the points. Okay, so basically based on the position of the points, basically it's creating a Voronoi. But I don't want this to happen. I want to create groups based on the colors. So here in the control attribute, I'm going to type CD. C in capital letter, D. As we have 2 colors, we need to define that the cluster number needs to be in 2 because we have what? Black and white. Great. So basically, I'm creating an attribute that is called cluster, right? So the cluster needs to be promoted from points to primitives, because then I'm gonna extract my meshes, polygons based on those primitives. So I need to promote the cluster from point to primitive, okay? Average is okay. And then what I'm gonna do is I'm gonna grab all the borders in order to clean them. Okay? The way to do it is by using boundary, attribute boundary. So what I'm gonna do here is I'm gonna select the borders of the clusters. So basically, by default, it's grabbing just the borders, the general borders of the mesh, because it's being selected by the UVs. So by UVs means it's selecting all the borders of the UV map. But in this case, I want to select all the lines that I created in the cluster points component. So instead of using the UV as an attribute, I need to select the cluster as an attribute. So now it's selecting all the borders, which is great. So the next thing is to use the smooth edge or the edge smooth in order to fix those lines. Oh, the group that I created is called this one. Oh, we can change the name. Let's change the name. Let's put cluster border. Okay, this is the name, cluster border. So in the next component, I need to define that the borders that I want to smooth are the ones that are in the cluster border. Let's wait a little bit. And let's see. If let's see. Can we see it? If you see carefully, I can see a line. Okay, this is the line. So basically, the higher this number, the smoother this line is going to be. So if I change this filter to 1, it's going to be really, really, really polygonal. Maybe let's just put 100 filter quality in 1. And this is basically how I clean the borders, as you may see here. The thing is now that I have 2 clusters. I created 2 clusters, right? So what I'm going to do here first is I'm going to decide symmetry, right? So let's use a symmetry. So in this case, probably let's play with the positive X symmetry. Okay, looks fine. Keep in mind that you can play with different types of symmetry here. So for example, I could have an iteration in where I have positive X as the symmetry axis. Then in the second one, it could be negative, for example. Or then in another one, it could be in Z instead of X, like that. But another one could be like negative X, for example. So basically I have 4 different types of symmetry. I can grab the 4 of them. I can not merge, but using a switch node in order to check all those alternatives. I have 0, I have 1, 2, and 3. Let's keep it into 2, into 1. It's okay. Great, it's okay. Great. Let's save my file. So what I'm going to do now is I'm going to separate the clusters that I already created. Keep in mind that here in the group, here in the attribute promote, I create an attribute that is called cluster. So here I have 2 clusters. So if I click on the cluster attribute, I have 2 clusters, right? And I can separate them by using a blast node. Okay. So what I'm going to do here, it's now that I know that I have a cluster attribute on the primitives, if I go to the geometry spreadsheet in the primitives, I have a cluster attribute, and I have either cluster 1 and probably cluster 0. So basically I have 2 clusters. One of them are called 1 and the other one is called 0. So I can use this blast node and call a particular group back using a particular expression. So what I want is, I want to get access to the cluster attribute. So for example, in this case, I want to see the cluster number 0. So if I want to see the cluster number 0, there is a way to mention or to call a cluster, which is by typing the name, cluster. This is the name of the attribute. But here at the beginning, we need to type the at symbol, okay? The at symbol. So with this method, with this expression, I'm saying I need to see this particular cluster, but now I need to define the number of the cluster. So equals in this case and the number of the cluster. In this case, I want to see cluster 0. Click on it, and that's all. In this case, it's the opposite, like that. This is cluster number 0. And then if I want to see the other cluster, I can type cluster number 1. And now this is how I see, how I can separate my clusters. Cool. So what I'm going to do here is I'm going to go a little bit faster because I'm against the time. So let's use Delta Mush to clean the file a little bit. Okay, I'm going to pin the borders. I'm going to try to clean a little bit the mesh topology. So let's use maybe 30, right? Then I'm going to clean the normals. As we just divided the mesh, it's important to clean the mesh. Then I'm going to color it, maybe white. And then I can use our quick material. Okay, keep in mind that we are using MatCap. Then in the desktop, we had this pink color, which is really beautiful. And just in case, let's delete some small parts that probably we don't need it. So let's try to make it quite a bit bigger. Okay, that's fine. I think it's more than enough. And let's clean the normals as well. I like to clean the normals as much as possible here. So now that I'm happy with it, what I'm going to do is I'm going to type poly extrusion because now I'm going to extrude the mesh. So as you may see here, basically most of the work that I do that I've been doing here is extrusions. I'm going to extrude it through the point normal, the existing point normal, and maybe the extents too. Yeah, it's nice. It's nice. So maybe there, for example, what I can do is I can increase the thickness of the scale. Yeah, a little bit. Just 1.05. So it's getting nice. And again, probably I will need to clean the normals. Did it work? No, it didn't work. Anyway, let's see if, oh yeah, more or less. Okay, let's keep it like that. And then probably I can like smoothen the mesh a little bit using Delta Smoosh, but not without the pin borders. I'm gonna click on the pin border, maybe clean it a little bit. Maybe like that. 25 maybe. Great. Let's see if I turn this off. Okay, normals is okay. So now that I have this kind of shell, now I can give it the real thickness by using thicken. Let's wait. Let's see the value it has. Maybe how much? I use 1.5 now that I see in my notes. Yes, exactly. Now that I have thickness, let's clean the normals right now. Okay, those glitches maybe are happening because of my camera. So maybe if I change this number, yes. I thought it was the normals, but no, it was the camera issue. So what else? Well, I think the colors are nice, basically. And I can repeat this process, for example, with the other one. So I can copy, I can grab them, copy, close. I'm gonna save my file. I don't want Houdini to crash. I'm gonna copy it. But in this process, probably instead of going positive extrusion, maybe we can go negative. So in this case, instead of going positive extrusion, I'm gonna go the opposite. So let's see, maybe here it needs to be in 1. So maybe here, instead of -1, maybe we can go even more, like -25, something like that. Yeah. And then we can use delta smoosh. Great. Thicken again. And fixing the normals. And in this case, we can change the material maybe. Or we can keep this into the pink, and the other one could be, I don't know, black or gray. So basically we have those two elements. Great. So basically here we can merge them all together. And we have our structure. Simple as that. So the good thing about this is this particular methodology, I'm gonna keep this here. I'm gonna finish this exercise here. In the file that I sent you, you will see that this particular workflow is longer. So let me fix the camera again because I think I'm having a hard time with my camera. Yes, no more glitches. So the good thing about this methodology, it's that the only thing I need to change right now is the seed of stable diffusion. So basically what I'm going to do here is, instead of this number, let's use 1050. 500, sorry, 1500. Let's wait some seconds and my structure will change completely. Great. I have another structure. And I can repeat this process as much as I can. Keep in mind that each time I'm changing the seed here, I'm creating new data on my computer. So basically I'm saving the file or saving the image that I'm creating here in Stable Diffusion. I'm saving it on the computer. So this looks really cool. It looks really cool. So that means in my computer, now I have more patterns. Yeah, keep that in mind. This is a good way not to lose your images. Cool. So basically, this is how I created those patterns here. Okay. The way how I made like the upper structure bigger, it's by tweaking it with the former. So in my reference file, so let me explain it because we don't have too much time now. What I did here, let's wait it. Come on, you can do it. So basically what I did here, oh my God, I cannot make any note. Okay. Oh no. Okay, let's wait. So the thing is, on this particular process, while my computer is loading, so what I did here, it's, oh, come on. Okay, so what I did here is, on this particular point, I added a deformation. So in order the structure to be quite a bit bigger, so here you can use the taper node, you can use even the transform node, why not? But keep in mind that if you want to use, for example, let's imagine you want to use the taper node, it makes sense to use it manually in the viewport, right? So that's my only advice I can give you to you. Let's delete this. Oh my God, I have so much things going on the computer. Did it load? Yes. Okay, so the thing is that I used to have this regular structure. Come on, please load. Yes, I used to have this regular structure, and then I deform it, use it linear taper. Okay, that's the main difference between my my file and this one. Okay, then you can add more linear tapers, deformation, and so on. Okay, so let's go to the end of this particular file. Okay, nice. And here we have a RobNet. So let me explain you very quickly what RobNet does. So RobNet stands for this particular out environment. So basically, here I can prepare my computer to render. So what I used here, let me show you very quickly. So something that I usually do, for example, and how I got those images, those are not renders, those are sort to say screenshots in a way. So remember, for example, when we were In Rhino, we used to use this component that is called view capture to file. So Houdini has its own view capture to file, but it's quite a bit tricky to use. So the way how I use is by creating a ROP-net. This is by basically typing ROP network here. And inside here, I use this OpenGL component. So this is the component that helps me to just make a very quick screenshot by selecting the camera. We need to create a camera. So in this case, I have the camera 3, as you may see. So I just selected the camera number, and in the output image, I just selected where I want to save my file. Let's put test .png. No, let's put JPEG. Another JPEG, sorry. Okay, and just render. The resolution of the image depends on the camera. So basically here we define resolution with the camera component, not the render itself. So if this, I don't know why it's taking too much time to compute, maybe because of the live stream, but this is how you render or make a high resolution screenshot. That's the method I use. Oh yeah, that's the method I use to create this image, as you may see. So it looked like it's rendered, but it's just a screenshot, a clean screenshot. That's how I create very quick renders. So, cool. So that's basically how to use MLOPs. However, there is more. Let me see the time. We don't have too much time. So, there are 2 exercises left. Oh my God, those were really cool. So, as we don't have too much time, let's do something. After the break, let's take 10 minutes break. After the break, I'm gonna explain more or less what's happening here by going step by step. Instead of creating this script from scratch, I'm gonna explain what's happening here, like the most important parts of the script, okay? Because I really wanna explain this last one. Because in this last one, I try to guide MLOPs in order to obtain something particular. As we don't have too much time, let's take a 10 minutes break. Okay, so in the last 30 minutes, maybe this will take me 45 minutes more or less. I'm going to explain what's happening in this particular workflow and what's happening on this particular workflow. Okay, so it's 2021 to 21 here, and I'm going to turn my camera on. I want to stop sharing screen, and let's take 10 minutes break. Okay. And then let's come back for the final part of this webinar. Okay, see you in 10 minutes. Hello again. So let's continue with the last two exercises. So what I'm going to do now, first is to share my screen. Let's see. Okay. So as we don't have too much time, and there are two different exercises here. So what I'm going to do is I'm going to explain, I will try to explain in detail as much as possible here what's happening on the files. At least in this first one, as you may see, this particular workflow, it's very quite similar to the previous one, in where I'm creating a pattern, a 2D pattern, which is basically similar than the previous one. But maybe the hardest part of this workflow is, let's call it this way, like the post-production, where I'm doing a lot of hard surface modeling here. And even you will see it's the first time you will see something like that in where I started using loops. So let's try to see, to go in detail with this. I know that you are already familiar now with the positive prompt, the negative prompt, the latent, which is basically the seed, the place where we select or change the seed. So I know you remember this. Once we create the prompts, we need to encode them in order to convert them into tokens that can be usable for the scheduler. So basically, the scheduler is the one that gather all of them together in order the solver to run. So at the end of the day, the one who does the magic is the solver. Basically, this is the one that is stable diffusion in action. Just keep in mind here, we have the possibility to change libraries. So, but for now, I am not going to change libraries because we could make our stable diffusion stop running. So I just prefer to stay to use one model here. But in the file that I sent you, I explained how to import different models. So if you have models in your computer, you can convert them into checkpoints that this solver can use. So the only thing you need to keep in mind is if you change the model, for example, here in the solver, you need to change the model in each one of them. Okay, so that's why I don't want to change it now. Once we run our solver, we need to use the decoder in order to convert the tokens or the numerical data into color. Okay. The thing is that we don't need the actual points. We need the image. I mean, the pixels, right? In this particular exercise, I use the upscaler. Okay, you can scale here your image as big as you want. My goal here was to upscale them in order to have more details. Keep in mind, when using the upscaler, here it was in MLOPs. I think it's utilities. We have here the real SGRAN upscaler. When using the upscaler, computer will take more time to iterate, okay? Because we are running the solver, the one which is using the GPU, and again after it we are running again our upscaler that also use our GPU. So each time we iterate, we need to wait our GPU to do two different tasks. Then here I'm exporting my image. So basically, at the end of the day, you know now that what this expression is saying, that I'm saving my file using the seed number or the seed as part of my file name, right? This expression $heap basically stands for this means that we're saving my file in the original folder where my Houdini file is saved. Okay, then in a node folder and my file. Okay, so that means that if I'm saving if I created my project in the desktop, this file will be saved in the desktop. If I create another path for it, if I use this expression, that means that each time I save something, it's going to be saved on that particular folder. Okay, that's what $heap means. So once I created my image, I can go back to the trace. But the main difference now that I'm using the trace node is that I don't have any copnet component. So it doesn't make sense if I use cop because I don't have any cop path. I have a file. So basically what I'm doing here is I'm importing the image from my computer to Houdini. So the thing is, I want to import this image each time I save it. So I want to repeat this logic name each time I import an image. So what I did is I copy this parameter and I paste it here. I pasted, what is this? No, sorry, what I did here is I save the path of the computer iteration image path. Oh yeah. Yeah, what I did here is I copy this parameter and I paste it here. I pasted the parameter here. Okay. Inside here, sorry, paste the value. So basically it's saying, what it's saying is, here it's saying, we can import whatever was saved on this particular path. So if this file was saved in the desktop, so now my image will be loaded from the desktop. This is what this expression is saying, right? So the only thing we need to keep in mind is that in order this workflow to work, as we are saving a file on the computer and uploading it again, if we want Stable Diffusion to recognize that process, we need to keep the trace node in preview mode on. If we turn this off, once we run our iteration, Houdini won't recognize this node. I don't know exactly why this is happening. I think this is something that needs to be fixed in later versions of MLOPs, but for now, this is not working directly. Okay, this is a problem that I found here in this method. So that means once I import my image, that it's somewhere there. So that means, for example, if I go back and I go to my latent noise and I change numbers, it will work. But if I, for example, go down here and I turn this off, and I turn this off, probably if I change noise, probably this won't work. Oh, it worked. Fine. Well, let's put 50. Oh no, it didn't work. Right. It's not working anymore because for some reason I lost connection to Stable Diffusion. This is super weird, honestly. So the only way I found to solve this is by first I need to turn this on, the image, in order Stable Diffusion to run. So let's wait. Then I'm gonna turn this preview on, and I'm gonna turn the trace on as well. I need to reload the image here, turn this preview on by pressing Shift. So now if I go back to the transform node, so as the previous nodes, the preview mode of the previous nodes are on, now I can change the seat and Stable Diffusion would run. Okay. This is how this is the way I found to keep Stable Diffusion running each time I make an iteration. Cool. That's the only main comment I wanted to make regarding this workflow. Okay, let's work with this particular object. So the procedure from this point onwards is more or less similar than we already seen, in where we have the pattern. The pattern, it's more or less pixelated. So I go to ends. Oh, sorry, I need to, let's see, did it convert it into lines? I don't think so. Let's see what happened here. Let's check. Oh yeah, it's working. I don't know why it didn't work. Okay. So the procedure is more or less the same. We have, I need to have this on here as well by pressing Shift. Great. So we have the curves. I resample it. Okay, then I smooth the curves to make it smoother on the borders. And I delete some small parts because from this particular point, I have so much details that I don't need. Then again, I have my the subnet we created in where we were differentiating, we were separating open curves from closed curves. So basically I have my operation here in where I can select open, I can select close. So basically I have close here, open here. So from this point, more or less the workflow is more or less similar. I transform, let's turn this off for now, as I am not gonna iterate it for now. I rotate it in a way this is horizontal. Then I match size in order it to be on the center. And then we have this attribute bob. If I turn this on, you will see that something is happening. It's been deformed. So what's happening here, let's go inside the attribute bob. I have the input. Okay? So basically I'm using position to displace it. So this is something that we did on the, I think on the first exercise and the second, I guess. But in this case, I'm using a noise that is called unified noise. So the unified noise contains, let's see if I can see it. Yeah, the unified noise contains more variety of noises. Okay, so we have the well-known purling noise, and we have the probably one of my favorite, which is Manhattan Cellular, which is a variation of a Voronoi. So I'm using basically the purling noise. Here, I'm using the purling noise as a color output, but at the same time, I'm multiplying this purling noise again with a multiplier here in order to control more or less the amount of extrusion or transformation or displacement. So that means this is something that we did in the first exercise. The main difference is that I'm using the same noise to the color output. So that's how I'm painting, or that's how I'm applying the color to the object. So basically, the deformation, the color, more or less match each other. Let's go back here. So I have this amount. So the amount is the one that represents how much it's been extruded. So let's keep it like that. Okay. Then I'm extruding it, and this is something that we already done previously. But this component is new. Here I'm using the polyfill. So the polyfill component help us to close when a mesh is open. The thing is, this particular component works fine if we have closed curves. So that's why I decided to separate it closed from open curves, because on this particular workflow, I mean, in the process of transforming or editing closed curves, I needed to convert the closed curves into meshes or surfaces or planar meshes, and then volumes. That's why it's important. Then I cleaned the normals and I apply color. So this gradient, basically, it's changing or editing the original color. Okay, so the way how this gradient's working, it's because it's basically reading the previous gradient. So it's like replacing that gradient with the colors that I want. In order that to happen, I need to define that I want to change my color type to ramp from attribute, because I'm going to edit the color itself. So if you want to change color, for example, in this attribute ramp, we have on this wheel, we have presets you can play with. Okay. Oh, this is really cool, by the way. Okay, let's keep it like that. I was really happy with this variation. I fuse them just to be sure that we have closed volumes, right? So the good thing about this is now from this point onwards, the hard surface modeling technique appears, where first I created my base. Okay, this base, this is not the base. I think this is the base. Okay, this is the base. So here, if I'm gonna turn the preview on just to see what's happening here. So I made the base more or less, which is a grid, you may see. I extruded the mesh as my faces were as my faces were like pointing inwards. I reversed the mesh, and then I use a BTB. Let's look it like that. I use a BTB to convert my mesh into voxels to clean the mesh, okay, in order to have something like that. a kind of mesh that is really thick, because my goal was to use this object in a Boolean operation. So what I did is I extract this shape from my actual cube in order to have something like that. So what I'm using here, it's something that is called Boolean difference, or in this case, Boolean subtract. So if you type a Boolean here, I'm sure all of you already know what Boolean operation is. We can intersect, shatter, subtract, and union. So in this case, I use subtract in order to have this kind of blueprint, guys, if I can say that way, on my cube. So each time I run a new iteration, I'm going to have a different footprint here. So let's go back. For example, I'm going to turn this preview on. I'm going to turn this preview on. And I'm going to run another iteration. So let's go to 60. And let's wait. So we will see how the footprint here will change. Let's wait some seconds. Okay, it changed. So that means that Stable Diffusion it's running properly. Right? So let's do one more iteration here. Let's wait. Hopefully the output will be cool. Well, not that cool. Anyway, let's continue with it. Let's see. Oh well. Anyway, not all the iterations are cool. But if I'm not mistaken, I was using 50. Is it okay? I don't remember. Anyway, let's work with whatever we get from now. Come on, you can do it. Oh well, cool. Let's go back. So then on the next step, what I did is I grabbed all those borders, all these borders here, and I used the poly bevel just to clean a little bit. It's like to add a fillet edge. Okay. In order this to work, in the Boolean operation, I need to turn on a group on the edge. So basically, the group that I use is AB seams. Okay. So this is the group that I'm using here in order to do this kind of fillet. Okay. If I do not define this group here, Houdini will try to polybevel everything, and I don't want that to happen. Okay. Then we have here another Boolean operation. The thing is that in our original image, the one here, I have this kind of ramp. Not sure if you can see it. I have this kind of ramp. So basically what I did here right now is this Boolean operation here, but now I need to know another one, the one that represents this ramp here. So just I need to model the object, something like that. And again, I need to make another Boolean operation or a Boolean subtract. Okay. So let's delete everything. Let's go back to the file here. So I have a box. Then I grouped one of the faces. In this case, I am not grouping manually by using the base group. I am not using either the bounding regions or the include by edges. I'm using this way of grouping, which is keep by normals. So keep by normals basically select faces depending on its normal. So in this case, I'm selecting the faces that are facing this direction, which is the positive Z. So positive Z is this vector. So basically I'm saying select everything that is facing that direction. So basically, as this is facing this direction, it's been selected. Okay. Let's clean this drawing. Then I am moving the object to the origin and transform it, but transform it depending on the group. As I create a group number 1, I'm transforming the group number 1 in order to make it smaller, just this face to make it smaller. Then I'm just editing everything. And this is the object that I'm using in this Boolean operation. Something like that. Okay. Then cleaning the normals. And that's how I get my base, the base of my project. Then I go back here to the object per se. I change color. Let's turn the wires off. This is my object, which is really cool. I just apply a very quick material using the quick material. I clean the normals just in case. And this is my second output. as you may see. So basically I have the base, I have my building, and I have something else. In this case, I work not only with the closed curve, but the open one. This is the first exercise in where I include the open curves as part of the designing. Basically, I repeat the process to transform it, to put it in the origin. I use another attribute Bob, as you may see here. So if I go inside here, in the unified noise, I am not using purling noise anymore. I'm using SideFX, which is a variation of a Voronoi. Okay, but the logic is the same. So the main difference between this attribute Bob and the previous one is that in this previous one, in the unified noise, I was using the purling noise. That's why it looks more curvy. Then in the previous one, sorry, in the new one, I'm using the SideFX, which is a Voronoi. That's why it looks more polygonal. That's the main difference. Apart from that, the process is the exact same. As they are open curves, there is no reason why I should use polyfill because there's nothing to fill. They are open curves. So if they are open curves, my results are just surfaces in a way. That's why I use directly thicken in order to convert them in this kind of walls, as you may see here. I have just walls. I'm going to clean the normals in order for them to be more obvious. I'm going to change this to perspective. Come on, perspective. Okay, that's better. Okay, I fuse them just to be sure I'm dealing now with closed volumes. I changed the color to white in order to add this quick material from MatCap. And here, this is something new. You will see that I have an attribute wrangle I call alpha. So what alpha does, so I'm going to copy this expression to the chat. Okay. What alpha does is basically it gives me the possibility to add transparency to my object. As in Houdini, we have a transparency attribute, but we don't have a component that could let us change the transparency of our object. That's how I control it. So another way to control it, instead of moving, for example, this value manually, I can create a slider. So the way to do it is by defining a channel float, parentheses, quotation mark, and the name of the slicer. So the slider, so I'm gonna put it amount. If I click on this plus icon, we will see we're gonna create a slider I can play with very easily, okay? For some reason, my elements are disappearing. I don't want them to disappear, so I'm gonna keep this into 1 for now. I clean the normals. Basically, I have my other element and then merge. But I have something else, as you may see here. I have this kind of slabs all along the building. So I'm gonna go back a little bit. I have this curve. So another way to work with curves, it's by using an intersection between curves. So we have the possibility to do Boolean operations, but you know Boolean operations work with volumes, most of the times. But we can do this kind of Boolean operation with curves as well. So what I did here, first I delete some lines that I don't need, maybe the longest, maybe the shortest one, sorry. So then I create this circle. So the circle and the curve are more or less on the same location, because I'm going to use this component that is called curve intersection, okay? So basically this gives me the possibility to create an intersection between them. So now I can delete again, the ones that are open, the ones that are closed, okay? So this output will change depending on how I delete my curves depending on their length. In this case, I'm deleting small parts, but not based on the area because they are open curves. So I'm deleting them depending on their perimeter, so their length, right? So the idea here now is now that I keep closed curves, sorry, I fuse them, rotated 90 degrees. And from here, what I decided to do is what I needed is I wanted each part or each island, let's call them island. I want each island to be filled with, or to be converted in in a surface. This is, for example, what we do in Rhino when using planar surface, if I'm not mistaken. You have planar curve and you convert it into a surface. So here, the component that I need to use is polyfill. But the thing is that as we have so much independent items, it's better to run this process one by one. So first, I run polyfill in this first I run polyfill on, come on, I want to make some drawings. Okay. I don't know why I cannot draw. Okay, anyway. First I want to run the polyfill on this island, then on this other, and on this other, and so on. So basically what I'm trying to do is a loop. I want to repeat the process several times. And we can run loops here in Houdini. If you type for each, you will see that all of those components are loops. We can run loops in different levels. Okay. The one that I'm using is this one that is called for each connected piece. So what this particular group of component does, if I connect the transform to the connectivity, and if I go back to the final, to the output of the loop, you will see something very cool. Let me close my Epic Pen. It's not helping. Okay. If I go to the block end, so I mean to the end of the loop, even though I don't have anything inside the loop, I have this parameter that is called single pass. If I turn this on, I will have the possibility to see each group or each island. So that means that my loop is properly recognizing each island as independent items. That's how I can run now my polyfill, which is the one that I'm running here. So I'm running my polyfill using triangles. So at the end of the day, I can run a polyfill in each one of the closed islands in order to keep my model clean. Okay, and it's in a way it's faster because I'm running independently one by one in a cleaner way. So then I extrude them. Oh, let's clean the normals. I extrude them in order them to look more like slabs. I transform them, apply a material, and as I wanted to look more like we have like several slabs, I use the copy and transform node, the one that we use in the core exercise. But the only difference is that we are just translating the model vertically. Okay. So in this case, I have 10 repetitions. Each one of them are being displayed 0.25 units. Okay. This is my final output. I made a merge. And that's basically what we have here. That's basically what we have here. At the end, we have the output. So the funny part about this, let's go to the axonometric view. So the good thing is that if we keep these MLOPs, this MLOP and the trace node with a preview on like that, we can iterate everything. So let's use another seed. We'll need to wait a little bit more, but as soon as we keep these outputs, this export image and the trace component on, at least with the preview mode on, we will be able to run stable diffusion. So here I have another iteration that looks really cool. So another number. Just a reminder, this version of MLOPs uses stable diffusion 1.5. So that means we don't have an XL library right now. So it's better to keep the image smaller, not that big, not big enough, okay? So the good thing is that you can use an upscaler later, so it's fine. So everything is working pretty cool, I guess. It's working fine. So let's do one more. And this is how this works. Cool. And let's do this final one. And nice. So that's the cool thing about using MLOPs inside Houdini. We have this possibility to iterate faster than just by importing images. That's something that I used to do when stable diffusion wasn't a thing yet. Cool. Cool. The thing here, and I think, let me see if I have it. Yes. Let me explain you very quickly what I did here, okay? Because what I have here, it's a render. Okay? I have two renders. The one on the left was made in Karma, and the one on the right was made in Arnold. For obvious reasons, I invested more time in Arnold than in Karma because I use just Karma to make quick renders. Okay. In the other hand, I use Arnold like to create like the final render, with so much flavor in the color, in the lining, etc. So basically here, if you go to the stage tab, okay, or even if you need to go to the stage environment here, you will see something like this happening. Okay. So this is a very straightforward procedure to render something. Okay. Here in the stage environment, we need to create everything from scratch. So that means if we used to have cameras in the object network, probably here won't work. So we need to create it from scratch. So basically, the first thing I do is I import my objects using the sub import. By using the sub import, what I'm doing is, for example, here, as you saw here, each part has its own null component. So the null components in this particular part are so important that if you don't have them, it's going to be really hard to import the objects to the stage environment. Because what I'm doing here, I have the out 0, out 1, out 2, and out 3. Here on the stage, what I'm doing in each sub import, it's selecting the out or the null node on the previous container. So by selecting it here, I go to the previous container that was called workflow. And here I can see my out nodes. Those are the nodes that contain the geometry. That's how I imported all the parts of my geometry. Oh, this is the base mesh, sorry. Okay. The next step is to apply a material. Okay, hopefully I can see the material here. I don't know why I can see the material, but anyway. So the next step is to apply the material. Okay, I'm not going to explain it, but let me see if I can render it. Let me see if I can render it because I think there's a material that is not running. Maybe it's glass, that's why. Oh, okay, that's something that it's not running properly. And I think it's, why is this changing that much? No, this shouldn't happen. Okay, let's keep it like that. Okay, let's keep it like that. There is something wrong with this file. Probably somewhere here. Oh, I have a curve. That's why. Let's check. Okay. Okay, that's why. Can I delete height? But I cannot see my architecture, sadly. Weird, weird, weird. Okay, now it seems it's working. But for some reason, it was not working previously. Let me check. Okay, it's there. Anyway, I'm going to explain this very quickly. So what I'm doing here, the way how I use stage is just by importing the object using the sub import, and I create a material library. So once you create a material library component here, we enter in this place when we can create a shader. So if you are familiar with procedural texturing, this is how you use material X shaders in Houdini. Basically, Karma is optimized to be used with material X shaders. Material X shaders are very similar to Arnold. So that means if you learn how to use Arnold, Karma is not going to be that hard to be used. It's not that hard. So the same logic that you apply in Arnold is the same here in Karma. So basically, I'm creating my standard surface and applying some components in order to make it to apply. In this case, I'm creating this kind of curvature analysis that here is called phasing ratio in order to apply colors. Then here I'm applying, let me check, a transparent material just by tweaking the transmission, simple as that. And the first one I'm applying, I think, a gradient using fractals, yes. So yeah, I'm using noises here. I use a mixed component just to select between different types of noises. Simple as that. So once you combine everything, you create lights. We need to create lights manually. So even if we used to have lights in the object network, we need to create them from scratch here. Okay, so this is my HDRI. I have an HDRI on my computer. This is an area light. This is, I don't know why I have two DOMs, but then I have accent lights. I combine them all together. Then I create my cameras here. I combine all the cameras, and in order to render, I use the camera render settings. This is how we define the final quality of our image by selecting the sampling, the general samples, the diffuse, reflection. This is the exact same thing as using Arnold in Maya, for example. In this case, my render is running by default using the CPU, but I could use the XPU. What basically XPU does, it uses my GPU and my CPU at the same time. In this particular version, the XPU engine is in beta mode. This is Houdini 19.5, but now that the version 20 it's released, the XPU option it's fully assembled, and it can be used without any glitch. And I think even it has more options right now. And this is how I render. So if you have if you want to experiment rendering in Karma, you just can copy paste this logic and start tweaking things. Okay, I'm going to change it to Houdini GL because I don't want it to render anymore. And that's basically how this workflow is about. So let's talk about the final one, and that's how we're going to finish for today, at least. So in this final exercise, what I'm trying to do, let's close this file and let's finish with this. Let's turn this on. Okay, and I'm gonna let me check the other one. Okay. So if we see carefully, if we see this file carefully, we will see that we only have one component for stable diffusion. Okay, so during the previous exercises, we kind of create the procedure like a step by step. Remember that? First, we create the prompt component, then we convert the prompt into a token, then we encode everything, positive and negative prompts. Then we use a scheduler in order to define the resolution, the noise, the seed of our iteration. Then we run the solver and so on. Okay. During the whole process, you can even import ControlNet because there are ways to import ControlNet libraries. But in the second version of MLOPs, because this is the second version of MLOPs, the developers create this component that is called pipeline. So this pipeline, I'm going to turn this on, takes quite a bit of time to compute because this pipeline component contains all the components we used to have previously. So basically, it's everything in just one component. Okay, that's the good thing because it helps us to save a lot of time. We have here the latent noise, we have the prompts, the scheduler, even the solver, right? The solver is down here. The good thing about this method, the good thing about using the pipeline, it's apart from the positive prompt we have here. So basically, this is the positive prompt. You can check this file and play with it. I have here the negative prompts. I'm using the scheduler as it comes in default. We have one more parameter that is called guide image. Okay. The good thing about guide image is that I can use any kind of image I could create on others on other software, or even a render that I already made in, I don't know, in Arnold, in V-Ray, whatever you want. So in this case, what I did here is, let me copy this path. This is these images, if I am not mistaken, I shared to you those images as well. So those images here are some of those that I already created in Midjourney. I have more in my computer because I've been training my own library using this kind of inputs. So this is just one of those images that I extracted for the webinar. So those are the images that I already used to train Stable Diffusion. But as I didn't have enough time to have my library ready, what I did is I import an image to the guide image parameter in order to more or less pre-train the Stable Diffusion. So the good thing about this is that now that I can change my seed, for example, let's put it 25, for example, my output, it's gonna look more or less than the train image. And that's what I need in order to create, well, that's what I needed in order to create this kind of elements, okay? So basically, I'm using the match size to put it on the origin. Here, the logic is the same. I export the image and I re-import it again, okay? I convert them into vector. I use carve to clean the curves. The good thing about using carve in this case is that we have the possibility to more or less define. Let's turn this. Let me turn this off. Okay. The good thing about the carve node is I have the possibility to define if I want to, how long of the curve I want to use, the length of the curve I want to use. The good thing is that you can animate this if you want. So you can create this kind of animations later. I didn't do it yet because my goal is not animation for now, but I can do it if I want. Just by animating this value, this slider. I'm gonna keep this into 1. Then I use the transform node to rotate it again. And from this point, the logic is the same. I use the fuse node just to be sure the curves are all together. I use my component, the evaluation neighbor, that give me the possibility to select if a curve is open or closed. I create the normals. That's something that we already did. Let me make the normals quite a bit bigger. Just that. So by default, I don't have by default, my points don't have normals, so I need to create them. Now you know how to create normals. Then instead of deleting open curves and closed curves, I use this split node. Split node, that's what its name is suggesting. It splits an object depending on a group that you created. As my evaluation neighbor component creates a group that is called isOpen, I can split based on that name. So again, let's check this file. Let's see. Okay, something is happening inside here. I made on the cluster. So let's check what is happening here. So what I did is I imported the curves, I extruded, I put in the origin, I added a little bit of thickness, clean the normals, delete some small elements, transform it again, put a color, and that's everything. Why did I convert this logic into subnetwork? It's because I want this procedure to happen all the time. So it's better for me to convert it into cluster. Okay, I apply the material. Probably I did the same here as well, but probably rotated in the opposite in another direction, because my goal here is to not to extrude, not to work with objects in one direction, but in this case, 2 directions. Because when we intersect one element with different vectors, in the intersection, something interesting happens, usually. That's why I'm combining 2 different rotations. Cool, I apply materials here. So let me turn this on. Let me see what's happening here. I see that I am editing a lot of things. Let me check. Okay, let me check it very quickly. Oh yeah, What I did here is I created some additional elements that will be used to subtract pieces on my particular extrusion. The thing is that as I'm doing an extrusion, a very simple extrusion, I want to add more flavor to the object. So maybe I want to make this cut, I want this to disappear, or maybe I want to make a hole here. So a method to do it, it's by creating those objects that are going to be used in a Boolean subtract. So what I did here is I use this object, I use this bound component in order to get a bounding box. I selected the front face. So at the end, I am using the same bounding box, well, a transformed version of the bounding box, and I'm copying it in each border of the face that I selected. By using the attribute randomize, and this is something that we used previously, I have a copy each box with different size. The good thing is I have the possibility to change the seat. Hopefully, okay, it's not changing because maybe I have a control somewhere. Okay, I have a control here. Where is it? Okay, let's go with it later. We have the possibility to change random attribute is called. Oh, it's this one. Oh, I cannot change it. I made a whole procedure for this. I'm going to explain it later. So with that said, I am like deleting and I'm adding this kind of detailing flavor to the object. So it's not like a regular extrusion. It's an extrusion plus a Boolean subtract. This is how I start adding details. Then I copy it in order it to start looking more like a building. So the good thing is that I have the possibility to add more levels. Okay, that's the word. Here, probably I add another workflow to add more details. Let me check. Yes. So in this case, I am creating another workflow to have this kind of diagonal sections. Okay, this is more or less the same. I create a bounding box. I have groups. Okay, so those groups, I'm copying an object in 45 degrees. By using this sort node, what I'm doing is I have the possibility to change the position. The reason why it's green and I cannot change it, it's because I have a remote control at the end. So it's not giving me the possibility to change the number. So the thing is that this particular file is that complex that I need to have a remote control, which is this one. This is the remote control I created. So basically, if I change this number, probably everything is going to change here. Yep. Yeah, it's happening. So, okay. So this logic, it's more or less the same here. So this logic, the logic that is happening here is the same as the next one. So the main difference is that the other object, it's like more or less vertically. Okay, it's like located vertically. Then I have my horizontal and vertical objects. Cool. Let me turn this on. I'll use the preview button. Because what I have here in this remote control, what I created here, and that's something that you can do easily in Houdini, you can create remote control. The remote control is the use of a null node. Okay. And in this null node, you can import any kind of parameter you want. So for example, if I want to change, let's see, let's do something very quickly because I think this could be helpful. Let's imagine I have a box. Okay. I'm going to make this box like really huge. Okay, let's imagine I have this box. But I don't want to control the box from the parameter itself, but from a null node. So let's imagine I want to control the scale from this null node. What I can do here is I can select the null node. I can go to the edit parameter interface. And from here, I can grab, like, for example, a float. I can create a float parameter. So this is going to be called, I don't know, box scale. Okay, for example, this is going to be a float and the range will go from 0 to 1,000 and apply. So what I made here is a slider for something that it's supposed to control my box scale. But nothing is happening because I didn't define anything yet. So what I need to do is right click on the parameter, copy parameter, go back to the box in this case, right click on the parameter I want to control, paste relative references, enter. But that's all. So now it's green. So that means that now this parameter is controlled from the null node, like that. So I could have I have the possibility to have several elements just controlled by this box scale. That's what I did here, but I have more parameters, right? So let's go to the final part, because this particular element was symmetrized. And I'm finishing with this. And that's basically everything I have it here, because I have the possibility to change values from here. I can change, for example, stable diffusion sit. Let's wait some seconds. It will change the patterns. Let's wait a little bit because everything is running. Hopefully this will run faster. And it changed completely. I have the possibility to change the multiplier for the open close curve. I have some additional parameters. All of those three are just controlled by one parameter that is called randomize it. So I just need to click on this number and everything will change here. Basically the cut sections, it's changing. And from here, I have the possibility to change amount of levels of my building. Simple as that. I have 2, now I have 1. Simple as that. So finally, I repeat this process horizontally. So basically what I have here is the exact same process, but doing horizontally. So basically, that's everything you need to do. Let's put it into 5 levels. And that's how I came to this building, just by trying to look for a proper iteration. Okay. So let's go outside. Let's turn this on. And that's basically everything I wanted to show you today. So feel free to edit the files that I sent you. Feel free to ask questions whenever you want. Take your time to rewatch the video. If you have any questions now, I'll be happy to answer. If not, send me messages whenever you want. Don't forget to tag us, tag me, and tag Design Morphing in anything you explore from this point. So for me, sadly, we won't have bonus track today, maybe in a future episode. And well, that's all from my side. Thank you so much. Thank you for your patience as well. Thank you, Paulina. I think that's all from my side.
Thank you, Pedro. Let's see if we have any questions so far.
Sorry, could you repeat? Because I had
I was just saying, let's see if we have any questions, but I guess
hopefully.
we can.
I know there was a lot of information because using stable diffusion is quite tricky in Houdini, as you could see.
But very relevant. It was really fun, like to watch this workflow. Thank you so much for sharing.
I'm really happy to share it. Good thing is, you will have time to watch the video again and again as much as you want. I don't know for how long, but try to do it as soon as possible.
Yeah, we're going to send the video, I think, in a couple of days. It might have like 1 day delay, like from the usual time frame, but it will be there next week.
Nice. Well, if there is no questions, it's fine. Take your time. I'm gonna be there in Instagram to answer your questions. Whatever you want. Thank you, Paulina, and thank you to Design Morphine for this second opportunity.
Amazing. Thank you so much, Pedro. Always a pleasure. And thank you everyone for joining us today. And I'll see you around. All the best. Goodbye.
Thank you. See you later.
Bye-bye, guys.